I think so. It's like having trouble, it looks like. Okay, well, anyway, it works now. Okay, so same as yesterday, I'm gonna start with some DSL, like language stuff, and then we're gonna switch over to RPG. Okay, I did make some progress in between here. So now we can bind variables and, well, crucially, like under the hood, I had to kind of change how the parser works. So I realized that actually for the parser monad, this is the old way that I was doing it, like the previous way. Old as it has existed for a long time. No, it hasn't, but the previous way. So instead of having a comp time function t, you can have a type on the field instead. The issue with this, though, is that the type is not like embedded. The payload type is not now embedded in the type itself, which leads to some problems later, which maybe I can show, but well, mainly for the bind function here. The bind function has no way of being able to extract the payload type without actually calling this function first. This function is producing a parser, but we have to have the actual field to know the return type. So when we try to say that, okay, well, yeah, okay. Bind, okay, so let me show some Haskell notation here. So bind is actually, it looks like this in Haskell, but I will just call it bind here. This is bind. So bind is, I don't remember if they have 2 or 1. I think they have 2, something like this. Bind has like, well, first you have like a monad M, and then you get like a monad. So this right here is like, M is kind of like a function that takes a type. It's kind of like a comp time function in Zig, where this is an argument and this is the function. However, the argument is, where does it come from? It kind of implicitly is like a type variable that you also put into the system here. So it's like it's gonna be, I think the term is polymorphic, I think. But it's essentially not populated yet, so it's an unknown. Essentially, it can be anything. And then, man, I forgot about the. Yeah, it has to be this, right? This is the notation. I forgot about how this looks. But then you have and then you have a function, which is denoted like this. You have a function that takes A and returns a monad B. So B is another unknown here. And then the whole expression results in a monad B. So essentially what this means is that given a monad with a payload of A and a function that takes A and gives a monad of payload B, you get a monad of payload B. Because you're applying this function kind of on this monad to kind of turn it into a monad B. Now it's different from like map, which is it's called like fmap in Haskell, which actually takes a functor, but I'm gonna say monad here just because to make things simpler here. Now map only takes A to B, so they are very similar in like the signature, but there's a crucial difference, is that bind can actually like change kind of the monadic construct a little bit here, while map can only operate on the inner value, while bind can do a bunch of other stuff. Essentially, bind is more powerful, essentially. And you can, in fact, you can define fmap in terms of bind to say fmap ma f is equal to bind bind on ma, and then let's say we take a here, and actually is it this or this? I forget. It's probably this. So this is a lambda in Haskell. So you take a and you return a. Okay, this is the same thing. Return is also a function, actually. Return takes a it needs a mode and m, and then it simply returns a into the monad, essentially. So I'm trying to define bind here, but as we can see that bind has like one variable here, which we get from this parser. So we have this available because we have the actual parser, like parser.payload. That is going to be a there. And f, which is a function that takes a and returns a monad of b, and then the whole thing should be a monad b. So this is supposed to be a monad b that we return. The problem is here we're supposed to put the payload type here, but we can't actually get the payload type here because the payload type is only available in the function itself. So here's the payload type, but we can't like put it here. So this is the whole issue. So that's the issue with putting the payload type into a field like this. Hello, Penguin. And the reason why I did it like that is because I had to do it like that for another reason. Not in this monad though. So I realized that, hey, why don't I just use normal comp_time functions for this? So if we now go to parser 2, which is the new one, and now we go to the parser here. Now this is a function here. Instead, it takes a t payload type, and we simply, it's simplified also this thing here. So now we have just a function which we can have the full type of. So we have the parse function with the payload t, and this one is simply a function that takes well, it produces this parse kind of function thing here, which takes a parse context and can return a parse error or the payload type here. And this is the whole parser. And then I also expose this for convenience so we can easily get to the payload. But crucially, we can get to the payload through the type itself. We don't have to. Did I say hello, Penguin? I think I did. We don't have to, you know, get a instance of this struct before we can actually access the payload type. We can access the payload type directly through the type itself. And this allows us now, if we go down to bind again, to take a parser. The only thing here is that, okay, I'm gonna go through this first. So this allows us to take a parser. Now I'm saying any type here, but ignore that for now. And a function any type. It's just because it's kind of our way of saying we don't know A and B. So because we don't know A and B, we need to kind of have that as input. So that's why we put any type here. There's no way of doing that right now. Maybe there will be a way to do that in a future Zig version, because they are gonna. What I've seen a proposal for changing the way you kind of bind type variables, which will be really exciting actually, because then maybe we can have expressions like this. That's gonna be awesome. If that's happening, I won't get my hopes up. But anyway, it's possible now anyway to write this function, because you take a parser, you take an f. Now we cannot trust that you give in a parser an f, but if it's not, if it doesn't fit the pattern, it's gonna be a compile error somewhere. But then we can just say that, okay, well, the result will be the return type of f, because remember, f is this. It returns the MB. So the result type is just MB. It's just the same as the return type of f. So this is super simple now to get this type here. And then the actual implementation here, we can just say, okay, well, give us the return type of f, that is MB, and then the payload of that, which is just that we can extract B from that. This is just a function that returns dot payload, and it works for both instances. And if you put in a parser type or a parser instance, it works for both ways. So anyway, so this extracts the parser payload. So there we go. Now we have bind, essentially. I think I haven't tested it yet, because yeah, I just made it last night, and yeah. But anyway, we also had an issue yesterday with the, oh yeah, that was the parser, the actual implementation of the parser for the language. We had an issue with this part because parse expression was a dependency loop. Because parse expression, it tries to parse one of these, and then this one goes in here, and then it parses it parses a sequence where it includes parse expression. However, before, well, if we go here, we can see how this was before. Before, I simply put this as a constant, like this, which you can do. And I tried to do this defer thing, which didn't work. But essentially, this was just this here, essentially like this, yeah. So this was how it was before. The problem was that now we have a dependency action dependency issue, because, or loop, or cycle, because this one refers to this one. This is also a constant, so they kind of refer to each other. There was the dependency loop. In the new one, I have a function that returns a parser instead. So now there is no dependency loop, apparently. So now this works. Okay, I was actually afraid that I couldn't get that to work, but it does actually work, so that's really nice. Cool. And we also have like map. Map takes a parser and a function. That's like the f map that I showed before. It takes a parser and a function that takes the payload of the parser and outputs another type. And so, for example, here we have parse binding. We have a sequence, which just means execute these things in sequence. So we have get context, which gives us the context. We have, well, I should explain this first. We put in a tuple into the sequence. This tuple is then the result. It's going to be the payload. So it's going to like execute everything in order, and then it's going to store the result in the tuple and output the tuple as a payload. So then you can have you can map that into a function that takes this tuple payload and basically uses the result of all these different things and maps it to something else, like a node that I'm doing here. So basically getting a bunch of information and parsing at the same time, and then I'm mapping that information into a node, which in this case is a binding node with identifier and the expression we're binding to. So yeah, the sequence is just get context, which is giving us the parse context, because we need that to kind of get the identifier kind of string content there. And then what's interesting here is that this is a monadic like value. It gives us the parse context, but it doesn't parse anything. It's not really a parser, but you can still use it to do stuff. So that's the power of this really cool like monadic combinator parser thing. And then we have, keyword const, identifier, and equal. This is all part of, these tokens are all part of Zig standard library tokenizer. So I basically get this for free, all this, like the tokenizer and all these tokens. So it's really nice because as long as your language is gonna look like Zig, it's a perfect tokenizer. And then it just parses an expression, and then we're done with this thing. So yeah, and then we're binding all that stuff to the binding here. So now an expression can be a binding, it can be an identifier, or a number literal. Number literal we had before is a pretty simple thing. It takes a number literal token. It will parse that using zig parse number literal. This kind of determines what type we get. So either it doesn't parse, or we have a, which it shouldn't happen because it already parsed it kind of here with the tokenizer. It knows it's a number literal, so we should be able to parse it somehow. So failure is like unreachable. But it could be an integer that is larger than we can store in a U64. So then it becomes a big int that we don't support right now, I guess. I guess we could. But yeah. Actually, you know what? We could just do this. We can just say parse int. Although we don't know the size. Do we get the size here? Base? What is that? Decimal? Oh, it's just a base. I wish it would give us like the size. Payload is the base. If it's not decimal, then the slice is duplicate. Because if we try to parse it, yeah, I'm just gonna say it's not supported. If it's a float, we're just gonna parse it as an F32. Catch unreachable, because we know it's a float, so it should work, unless it maybe we need like double precision. Maybe it doesn't work, but I don't know. Anyway, and then we have int. And this gives us the kind of, this already like gives us the actual value because it fits in like a U64. So it just gives us that. So anyway, that's parse number literal. And then we have parse identifier, which so what's kind of cool about this is I'm kind of using, Zig standard library. I'm mixing in, I'm trying to find things that I can use from the standard library to be able to kind of parse, help out a little bit and not have to write like a full parser myself and full tokenizer and all that stuff. So that's pretty cool. It's like kind of quick, like launch, start, whatever it's called, launchpad the project a little bit. Parse identifier is simply a sequence. We get an identifier token, and we need the context to get the actual string. This might actually be, well, this is already a function. It's parse identifier is the actual identifier function. Actually, we could use this. Yeah, we could just use this down here. This is also what's really powerful here, because instead of just doing token identifier, we can just parse identifier, and then we remove get context because we don't need that. And so we removed context, and then we replaced the inner part with an actual identifier. So this gives us a node. Maybe we want one version that gives us like just the string. Whatever. We get the node. This is the identifier node. Identifier is going to be node type identifier. Yeah, it's probably better to kind of get the string immediately. Parse identifier. So maybe I want another one, parse identifier S for string. So this gives us a string instead. Good morning, Ledju Luki. What's up? What's up? Welcome back. How's it going? All right. This feels so nice, by the way, to be able to work with this monadic structure. So this would be the same thing, but I'm gonna call this S for string. Super, you know, descriptive here. And this gives you a string out. And instead of doing dot blah blah blah, we're just gonna do lexeme, which gives us the string. So there we go. And now parse identifier will simply map parse identifier string to identifier string dot identifier. You know what? We could probably just use, yeah, we could just use node.identifier. We could just pass this actually, because it's gonna be the same thing. Yeah, and then we don't need that. Cool. And that's pretty cool also, like if you define your functions to take tuple types like this, you could just map that. There's a thing called currying in like Haskell and other languages, where it kind of changes the signature of a function. So let's say these were like, instead of taking one argument with the type of a tuple with a bunch of stuff, you take like 1, 2, 3, 4 arguments, each with the type corresponding to the items in the tuple. Now that would be uncurrying. And currying, no. I'm actually lying here. Currying actually means something else. I just realized. But it's kind of sort of, well, no, not really the same concept. No, forget what I said about currying. Currying is something else. It's like when you produce, it's like a chain of functions. Like you take, each function just takes one argument. That's what currying is. And then it returns another function that takes the next argument. It returns a function that takes the next argument, and so on. That's currying. This is uncurrying, because it takes a chain of functions and produces one function that takes everything either in as like a tuple maybe, or a bunch of arguments. Yeah, but we really probably, actually we could probably turn it into a function that takes, we could probably like apply. Wait, can you do that? Wait, there is a thing called call. Because, okay, so what I was thinking here. Well, this takes the tuple. No. Yeah, because it's different. Sequence doesn't actually call, like, apply a function. Unless we made a convenience thing called, like, sequence and map or something like that. But we don't really need that. Okay, but anyway, this should be kind of the same thing, except we changed some stuff, made things more composable, and just showing off like what you can do with this monadic structure here. So I'm debugging. I'm logging out the AST, which if we go to the actual source code. So here you can see the AST compiled to, first we have a binding, and the name is shown here, which is called variable, and can be confusing a little bit here maybe. And then, okay, let's just call this my variable, just to, and then we have to recompile. So my variable equals literal 5 is a U64. So that is like interpreted as a U64, I guess. I would probably rather have it as like an 64 or I32 or something like that. But anyway, yeah, actually, we could probably just do that. Wait, what if we put negative? Then there's an issue. Unexpected expression. Yeah, because this only is like unsigned int. I thought that this would... Okay, so maybe this doesn't work for negative numbers. That's kind of strange, though, isn't it? Because I think it's because negative is, yeah, it's treated differently, maybe. Parse number, literal. That's it. I wonder where all other parse stuff is. See, now I'm in Zig's standard library. And wait, builds of the Zig compiler are distributed partly in source form. That source lives here. These are APIs of proven analysis, no absolute guarantees whatsoever. Yeah. But I mean, that's true for everything in Zig. Okay, so right now, anyway. What is this? Bin name alloc. Just data name system. Sanitize, C, build, parse. Okay, so actually, I thought they had the whole thing in here. Maybe they don't then. Because it said like it only has like certain things in here. And now it's a bunch of tests. But I do have the tokenizer. And then there's like this server client stuff. Which has, I don't know. It's a bunch of tests or something, I don't know. It doesn't really have a lot of stuff. The client is really thin. Token. What is this? Token Smith. Generates a list of tokens and valid corresponding source. Oh, it's for testing, I guess, maybe? Like generating a bunch of random tokens. Maybe. Well, okay. I mean, what we could do is we could... So I'm not sure if number literal is... Do they have negative? Negative? No, negative numbers. Neg for negation. What about negative? Just minus. Minus. Yeah, okay. So maybe we have to parse like a minus before. Then. Okay. So, okay, is negated peak. So we'll peak for a minus, then it's negated. Which means it should be... So I'm thinking like if it's an integer, we should probably cast it to like an I64 or something like that. And is negated... I'm gonna say like if this is true, then we're gonna say -1, otherwise 1. So we can do like this is gonna be int and then times is negated. And then the same thing here for the float. And just to be safe, maybe floats also just do, let's just do F64 maybe. Actually, maybe not. Because then it's gonna be such a hassle converting it to raylib and all that stuff. Because that's what I plan to use, right? For actually like rendering stuff. Okay. We still get the error. Oh yeah, because if it is negated, we have to also consume... Yeah, we're just peaking. We have to actually consume... I'm just gonna like make a consume function. This will essentially just consume a number of tokens, and we're just gonna loop through tokens, and we're gonna call next. Oh. Okay. Oops. Expected bool for int. If it's -1, okay, there we go. Value ignored. Yep. We still get unexpected expression. Okay, I want to do something here. I want to be able to also log out all the tokens. So essentially, before we create the AST, I'm also going to just tokenize everything. And then I'm including this in the results. And then I want to log out the tokens. Although we won't get to that point though. I have to do like comp time log. Right. So tokenize text source. And this happened in comp time, so we just return this list. It's gonna be a read-only, like available in comp time. So we'll start with tokens as an empty slice, and then we'll return this in the end. And just to make sure we don't, yeah, we'll make a copy of the thing. I think we probably can just do this. Okay, we'll try it, and if it doesn't work, then it's fine. So here we're just gonna say while, well, we need an actual tokenizer as well. What's nice about this tokenizer also is that it doesn't need like an allocator or anything like that. So you can definitely use it in comp time, which is really nice. Although this source has to be like 0 sentinel, so, well, whatever. Okay, so now we have the tokenizer. So while next token, no, that doesn't work. We have to do like while true here. That's a shame. But so token is gonna be tokenizer.next, and if token tag is end of file, we will break. And but we will also, well, we probably don't need to like have end of file in the list. So if it's not end of file, we will reassign tokens to tokens appended by the token we got. There we go. So now we can build, now we're building up the tokens into a list. We get those tokens out here. We pass them along and we can print out the tokens. The problem is we are getting a compiler here, so we can't actually do that. So if we get here, I guess we can compile log the tokens before. tokens, and actually we have to do a contain print tokens. All right. And now if we run, whoops, what the hell? I've never seen that happen before. So if we run this, we should get a compile log, and here's all the tokens. Although I would probably rather have them be tags, actually. Yeah, let's just make them tags, actually. So we'll get the tag only. All right. So here is that. Tokens. So we have like const identifier equal minus number literal. So I don't. Okay. So, but I just wanted to make sure what it actually interpreted the thing to. So we do get a minus before, which I mean is good, but I don't know why it doesn't work. We get an unexpected expression. So the trouble is we don't have good error reporting, so we don't know where this error came from, essentially. Which could be a thing that you add to parse context, for example. We could add a report, like a diagnostics list, which is like, a list of diagnostic, which we can define here, diagnostic. Could be a union enum for the type, or it could just be a struct that has like, I don't know, level is something, and then we have message. Maybe we have a span or location, token, location. No, well, this has like a start and end. What about this type of location? This location has line, column, source line. We can't easily create it though. Well, we can create it here, I guess. Byte of the find line column. That's actually good. We can do this. Yeah, let's just use that. That will show us the entire thing. That's nice. Okay, and now we have a level, which is an enum. And this could be like, I don't know, info, warning, error, something like that. And we set it to an empty list. Now we can say, for example, we can have report, and we get a, well, we can make a diagnostic, I guess. Yeah. And this will simply say diagnostics equal to self-diagnostics plus. Yeah, I usually do this because it's, I don't know, I found this to work. And otherwise it will complain about something. So there we go. I usually have this pattern here. Okay, so now we can report diagnostics. Maybe we'll create a convenience thing here in it. I guess we could do like info, like for different of the things. But let's do it in it as well with all the things. Location gives us a this. And then you can have things like info, for example, message location. Actually, do we even need this? We just use init, actually. Yeah. The thing about the location, though, the location needs to be maybe, you know, the location, maybe we just use this function instead. So we pass in source and a byte offset that will, you know, give you the actual location. The problem is we don't have like a start and an end. It just gives you one location. I mean, maybe we could do use two locations. We have start is, so okay. Well, is there a thing called span in here? No, there's not. We can actually make a thing called span here, which will be start is a location, end is a location, and we'll make an init function. We'll make convenient stuff for this, but start is start, end is end. All right, and then this, instead of being just a location, we make we have a span. All right. And we can also have a function for like showing the actual span. The problem is, though, no. Yeah. We can do like show or like source, show or like get lines. We need the actual source code. And then we need, well, we need self, of course. Okay, and then this gives us this. And so essentially what we could do is we could do actually, you know what? We need even more information, I think, because these don't have like the byte offset. Unfortunately. If they saved the byte offset here, we could have used it. It just saves like line and column. Like I would like to have like the byte offset to the beginning of the location. Okay, maybe we'll just do our own. Oops. So this could be line, column, what do they call it? Source line. Yeah, source line. Let's also grab start index. So line start index. Yeah. And well, the line end index is just going to be source line plus that. So that's that. We need this. We can make this from the source and index. This gives us this. And here we can get like, you know, zig find line column. And then we just return line is line, column is column, source line, and then line start index will be index, I guess, minus column, perhaps. Yo, dear luck, what's up? My guess is that the byte offset would need more context if it's stored in lock. Yeah, I was thinking like if we store the start of the line, we can get the, like, we don't even need to store the source line here, even though it's a tiny kind of thing. From this, we could just get the source line anyway. What I want to do is I want to, because start and end might have different lines. So I want to get everything in between as well, not just the start source line and the end source line. So what I was thinking is if we get the start index of the line, we can begin from the start index and then go all the way to the end index. And we can actually do like a thing here. End index gives us, and this is just line start index plus source line length, I guess, maybe. Yeah. Bytes of the entire source versus just a source line. Yeah, exactly. Column would be, you know, just for the source line. And byte offset is the entire thing. So I want to store this. This is in context of the entire thing. And there we go. Okay, and then the spans has a start and end. And to get the whole thing, I guess we could have this function here. Get lines kind of implies you want a list of lines. Will that be easier? No. We could actually make an iterator because we can just return a split iterator. Line iterator, we can do like where is this? Mem split iterator U8, I think, delimiter type scalar, and we return init. No, wait. Oh yeah, we return split scalar U8, buffer is source, delimiter is that. However, source is not the entire truth. We want the truth, not the source. You have to check your sources, people. Check your sources. Well, the start index is going to be line start index. That's very easy. The end index, I mean, this is also pretty easy. End index, there we go. And then the truth is source start to the end. +1, maybe. We'll see. I think it's because this is like the length. It's like it's exclusive, I think, the end here. So, okay, cool. Using built-ins, standard library, awesome. And get lines, I mean, okay, let's also do like line iterator here. And this gives us a split iterator as well. And we just say return self span line iterator source. Cool. I mean, potentially we could just store the source on diagnostic as well. It's just a pointer, because then you don't have to like scavenge for the source. Yeah, let's just do that. Okay. I mean, I will store information that's needed to be displayed, in my opinion. Yeah. For convenience. Error parsing code. Yeah, yes, we know. Thank you very much. Right, so we have now diagnostic. We can report diagnostics. We can get out the source where the diagnostic happened. Maybe we'll do like some kind of format. Yeah, you can have a format function actually. That kind of just shows the diagnostic. So basically, I guess we'll do like print level, and then we have the message, and I will show and then we'll go through, we'll make an iterator, and we'll go through all the lines, and we'll write the line. And here you could format it such that you kind of highlight the part that is we're talking about, because we do have like a start and end position. However, I'm not going to do that right now. Maybe, yeah. It's just going to show the thing. Of course, we need an end line as well. Hello, Packler app. What's up? What's up? How's it coming along? It's going good. It's going good. Adding some debug information to like well, diagnostics reporting for the kind of language here, which is always nice. I really enjoy actually like making like, because I already made this kind of thing like a bunch of times, but it's all, you always, whenever you do it, it's a good practice to kind of do it again, because you realize some like sometimes you do get back to, oh, I just need to, you already made kind of the perfect, well, as you see it then, thing, so you can just copy it over. But sometimes you do like notice small optimizations and like improvements and stuff that you can do, which is cool. And I think in those moments you kind of, you know, you find better patterns and stuff like that. Can you provide additional context? Parts of the source code above and below diagnostic source. That is true. That is true. Yeah. And then the lines that are kind of marked, or the actual lines that we should look at, should probably be marked somehow. Let's do like that. Maybe we get some more information here. Yeah. Okay. But then it's not a split iterator anymore. We have to make like our own iterator. But that's fine. That's fine. Let's make our iterator here. Line iterator. So we'll have our iterator here, which is the splitterator. We have like start index is like where it should, where our marking start and index is where our marking end. So we'll have an init function. Start index and index. I guess they could be called lines, actually. The mobile lock selection would be easy. The context doesn't need to be part of the diagnostic itself. It just needs to be provided through a format that takes the additional context and leaves in the diagnostic. Yes. I'll just do it like this for now. Like, we can make it, because the problem is, we have an easy way to get the iterator for the actual lines, but we don't really have an easy way right now to get like additional lines. That's the issue. Because then we have to reach into the span. We have to kind of do it manually here. I would rather just expand this to always provide a little bit more, and then I would and then the next function provides like some kind of line here, and the line would have the actual like string, so source line or whatever, and then it would also have is within span or something like that. I guess type. Extra span. I don't know. All right, so next, so source line is iterator next, or else return null, and then we return source line equals source line. Actually, we need to keep track of the index as well, because otherwise we don't know. So type is gonna be if index is more than or equal to start line and index is less than or equal to end line, then this is span, otherwise it's extra. I know what I'm doing now is super specific and it doesn't really fit maybe into the span, but whatever. Maybe, I don't know. I don't want to, like right now I'm not trying to make the perfect code, I'm just trying to, you know, make it work here. And then self-index needs to be advanced. So that could happen in the end. We add 1 there. Okay. Cool. So now over here, we'll return a line iterator instead. And we'll return .init. With the line iterator, we have start line is, and then end line. There we go. Cool. And then you actually give us a line iterator instead. Let's actually span.line iterator. And then over here we get the kind of the line. This would be the source line. We could even have a format function for that, but I'm not going to do that. We are going to do, I'm just going to do this. If or switch line type, if it's extra, we simply print it there. If it is span, we can highlight it somehow. We could do, there is, I think if we do this, yeah, let's do it like that. So what I want here, we have source line, but before that, there's also like zig or standard. Forgot what it's called. Is it color here? No, that's not the thing. There's like a place, or ASCII. ASCII color. No? There's some place where you can specify colors. I forget where it was now. It wasn't ASCII. ANSI maybe? No. I remember finding it in the library somewhere. Log maybe? No. What the hell is macho? Math. Mem. Meta. POSIX? Perhaps? Okay, let's now H3 game zig stands zig color, I think. Yeah, I don't know. This doesn't seem to be the thing that I'm looking for. This, I think this just this is just like an option in the zig compiler or something. I'll check out. What's happening? Okay. Zig standard form, standard library, color, IO TTY. I think they moved it. Everything is in IO now. Yeah, here we go. All right. So IOTTY. Hello? Wait, why was that lowercase? What? Wait, why am I in 0.12? What the hell? Here we go. Color. Okay, it's here. Yeah, as I said, they moved everything to IO. Maybe they moved it from IO and then... What is this? Set color? Terminal T? What the hell is this? Mode? Huh, I've never seen this. Terminal. Interesting. Set color. This just writes out the color, I guess. Well, we don't really need that. We just need to actually just print the color out. I'm pretty sure this has like a format function. No? Wait. So you have to use set color. Yeah, okay. So you have to have a terminal. Where's... I mean, I guess we could just make this. It just needs writer and mode, so... But you don't have like an init or something, no. Why make it so convoluted? Okay, well, anyway. I guess we will... have to make a terminal here. Mode is, I guess, escape codes, I guess. Yeah. All right, cool. I mean, I guess, you know, it's pretty simple to create, so. But now I can't do it like this. I have to do... I wish I would just map them to their escape codes. But now we have to do like terminal set color. What's happening? It's because of this? No. What? Oh, it's because of this and this. There we go. Terminal set color to, I don't know. And also, is this a foreground or background? I don't know, yellow maybe. Wait, what about... reset? Okay. I'm sure there was a way to also clear it. Reset. Cool. And now we don't do all this. All right. Okay, so we have the format function. And now we need to report. Well, let's also go here. And this would give us... Actually, we need to do a couple of things here. This should give us the parse results. We need to have the node or AST or whatever. And then we can also pass in the parse context as well. So this will give us a parse result. This will give us the node. And then we... Actually, I guess this would be an optional because we might not actually have a node. Because it might go wrong. And context is context. And then the node is actually the AST. Problem is, this can be an error, so we're gonna catch the error. We are going to have a label. Oops, what am I doing? We're going to break null. So now AST can be node or null. And then we're gonna say report. Wait. No, we have to report from within. Right. Let's, you know what? Let's just catch null. Okay. All right. So now we have the context. So now we can say here, we can say that, well, this is the parse result. And it doesn't actually give us an error anymore. So we don't actually catch this here. So let's remove that. And the AST. So if we got the AST, we can do all this. Otherwise, we are kind of down here to handle the error. So we would get a bunch of diagnostics. The thing is, like, this is all in comp time, so you know what? Let's make like result. I don't know what to call this. Result. This would be union enum. Because I want two different, I want a success. This gives us this type over here. AST is a node. Oops. IR is an IR node. Context is parse context. No, wait, yes, no, yes, no, yes, no. No, it's the compiler context, compilation context. All right, Penguin. Or we have a failure or error or whatever. I usually say error. And the error will have diagnostics, or the... Yeah, I guess we could just have the diagnostics, maybe. All right. So if we're over here, we want to break out with... Oh, okay. This one is success. And this one is error. And you have diagnostics. It's gonna be parse result, context, diagnostics. All right. And now we're over here. So we have to do switch on compilation result. We either get a success. You know what? Let's just set this type to be result, because yeah, that's gonna be a little bit easier. Yeah, and now we can basically do all this crap here. If we have an error, we will say like compile error, and then we'll go through each diagnostics, and we will whatever, we'll format it. Yeah, so format diagnostic. And you are now result. And there we go. Cool. Now we can log stuff out. Compiler. Nothing. Because we didn't report any, we haven't reported any diagnostics yet. We know there's an error, but it's not being reported properly. So now comes the thing to actually report the errors. So and we have to kind of decide where that should happen. I think that in my in Runic, I think I included in the snapshots that like everything reported errors, but then if you had a snapshot and you restored it, it would kind of delete that those diagnostics that was. It would reset the diagnostics as well back to the previous thing. So, okay, but first let's, so the thing is, maybe we shouldn't. No, we should have errors, but we also report it. Yeah. Okay. The thing is here, like we could make, maybe we'll make a convenience thing for, maybe we'll do like, we can wrap this in like a potential like error producing handler. So like you would wrap this in like handle error, and then parse expression error handler, and then we would have parse error handler that would give us the parse expression and possibly the error as well. And it could be a map. We could also just have like, so the purpose of handle error would then be not to kind of catch the error, but more to just do a side effect based on the error that we get. Because try parse is kind of the way we catch an error right now. Yeah. We could also just pass in, I guess one-off could retrieve automatically like an error handler. Maybe. I don't know, because this kind of also, we are able, if we do this, we can kind of define our error boundaries as well. And so, for example, here, now we know that we have an error, and we could also get like, where did the error happen, for example. But this would be like report. Wait, parse error. No, parse context. Report, and then this would be init error, and then we have like a message and a span. You know what? Also, the message is probably, it's probably good to have this as a format. So you would have a format, so you could potentially, you know, format some stuff here as well. And then the span is something. We probably, do we get the span here, or we just get the actual location is the question. Because can we even have span? It kind of depends on, I guess we just get a token, essentially. The token where this happened. We could put, we could also make handle error could take a snapshot of the state before we call this, and then restore the, either restore the context. We could get the snapshot back. Snapshots, this is like the before snapshot. We could restore it to that place to get the current token. Or we just get the current token where it happened. Yeah, we could just get the token actually. Yeah. Token is token. We have a token. Okay. And so span, let's just do like from token. You need to be, so this would be format and then args. Yeah, sure, why not? And then we could, since this is only going to be using comp time, we could cheat a little bit here and use comp time print, format args. Okay, and then the span can have a init function that is from token. Wait, do we have token here like this? No. So from token, the start will be this. We kind of need source as well. So this would be like find. Actually, this will be like return.init. Yeah. And I guess. Oops. I think you can just do that. I'll figure out how to format this. This is the message anyway. Yeah, let's just have the error name as the message for now. I guess, you know what? Expected expression, which is like one of, you know, binding, identifier, number literal. We could probably, like, one of could maybe, if we could somehow embed some kind of way to like label these in the parser stuff, we could have one of be like produce automatically the one of these. But I'll just do this for now. Okay, handle error. We'll do this for a little bit more and then I'll switch to the RPG here. Handle error. So handle error is going to be, it takes a parser and it returns same parser, but it also takes a handler, which is a function that takes a parse context. What else did we want? It takes the token and the error. And it returns a void. Cool. Excuse me. Token. Oh. Wait. Toke. That's right. Toke. There we go. We have some stuff happening here. Expected type, blah, 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 found. Oh. Wait, this already has started. No, it doesn't. No, I thought oh, okay. I think I did this wrong here. I think I redid it like this. Yeah. Yeah. Okay. Hello, Woot Dragon. What's up? Welcome. Hello, I am a Windows enjoyer here. Can you tell me why I should get into Zig and why you think it's good? I mean, you can use Zig on Windows. You're not limited. I mean, okay, so I mean, Zig is a general purpose language. You can use it for basically anything, I guess. It is manual memory managed, so it's, you know, you can get very performant code, just like, you know, Rust or C, C++, any of those languages. But I think what stands out with Zig is the comp time stuff. And also a bunch of the kind of nice to have like quality of life features. So if you come from C, I think it would be an upgrade, even though some people swear by C. And if, well, I guess I will say it's different. I guess no, I would say it's probably an upgrade. From C++, I don't know really, because I haven't used C++ in a long time, so I didn't really ever get into a lot of the things where with the iterators and the kind of standard library and stuff like that whenever I dabbled in C++. But I will say that I did try it at some point, and I got stuck. I got stuck basically from the start, and it was just it didn't feel good. Yeah. But I don't know, what languages do you usually program in, Woot Dragon? And I guess it also depends on like what you want to do. Like, do you want to make a game? Do you want to make just a desktop application, or a terminal-based application, or do you just want to make a script, or Okay, C++, C++. Right. Yeah, so then it's like very close to those languages. It even has like very good C interfacing, so you can basically import a C library into Zig, and it will work essentially pretty easily, actually. And yeah, it's I think, you know, compared to C, I would say it's, as I said, it's probably like an upgrade. It has a bunch of nice features. It fixes a lot of things that C doesn't have and stuff like that. Although I looked at the things for the latest C version, or maybe it wasn't the latest, but it was I think version 23, and I was actually surprised they did a bunch of stuff. Like, for example, they now have booleans, like actual booleans. Welcome to the club. No, but yeah. No, what I really like about Zig is the comp time stuff. It's kind of like you can use it to produce types in comp time using. It's kind of like const expression in C++ and now C as well, but it's more powerful, I would say, because you can construct types using normal language constructs like loops and ifs and a bunch of different things, and you can construct all kinds of different types and stuff. So in that sense, I think it's more powerful. And I guess also it's like there's a difference, like there's the standard library like difference and some stuff, so you have to get used to it. But I mean, why not just try it? You know, just try it. It works on Windows as well. You don't have to install Linux to make it work. Nice, we can add core. You can basically tweak anything you want. Unlike other languages, you don't have to manually mess with everything in one memory one by one, unless you change things in a bulk. Compile time optimization and assembly generation are pretty good too, especially with maintenance version currently on master, which is going to be even better. Does Zig also have a way to custom bit with types? Yes, it has. Yeah, so I'm not really into those kind of like, I don't know, packed stuff and pack types and stuff like that. I've never really messed with that because I've never really had the need to do that. But yes, there are facilities to do those kind of things as well. You can have like, I don't know, you can have like a U1. Like this is just it's kind of like a bool. It can be 1 or 0. It's an unsigned integer with 1 bit. So you can define any arbitrary, like you can have a U13 if you want, if you really want to optimize like that. And there's even a thing where you can, let's say you want a type that is an unsigned integer with where you know what the maximum value is going to be. So max value, let's say it's like 347. Okay, now we know that the max value is probably going to be, you know, because 256 is 8-bit, so this would be covered by 9 bits. So we kind of know that already, but, you know, what if we do something like this? Now we possibly won't know how many bits there are we need for that, whatever. So if we want to make a type for this, we could guess like, I don't know, maybe 20 or something, I don't know. But if you really want to like calculate it, there's actually a int fitting range function, which returns the smallest, as it said there, the smallest integer type that can hold both from and to. So let's say we have from 0 and to max value. Now you get like an unsigned integer type that fits this range as a maximum. So yeah, just a taste of what comp time can do here, essentially. And I'm not sure actually. Does it work with floats as well? No, it doesn't. Float only has 32 and 64. I guess it's because it's like a built-in thing in like the CPU or something. I don't know. Anyway, unable to resolve comp time value. We have some stuff happening here, but let's do one at a time. Right, so here we can do source. Yes, there we go. Cool. So now we have from token. Or not. Actually, right, we just need the actual index. That's right. There we go. Cool. And now let's see. Let's ignore those errors for now. So handle error. So first we need these things to supply to the handler. So we need the token and we need the eventual error. I guess it's not. Yeah, this function might not get called because we might not have an error. But essentially, what I want to do is I kind of want to. No. This has to be its own thing. Yeah. So this would be init, and actually, yeah, because this is a parser type of parser, we can even say parser should get more type information here. We can say parser, and then we have the parser payload of parser. So we're kind of reconstructing the type so we can get this type here. Okay, and then we have a function which is handle error. This takes a parse context, returns a parse error, or a parser payload parser. Whoops. And then dot handle error. Whoops. No, it's over here. Right. Okay. So the implementation function here will grab out. So we'll store first. We'll store the token. So we'll do like peak. That is our token stored. So now we have the token. Now to get the error, we already have the context. So to get the error, we would have to run the parser. Yeah, run with the context. Now this could potentially make an error, so we have to catch the error. In the case of an error, we'll catch it, and we will actually, I can do return here. We will catch the error, and then so now we have the error here, and here we call the handler first. So we call the handler with the context and with the token and with the error. So there we go. Then and then we return the error. So it's still gonna error out, but now we call the handler. It's kind of like, yeah, it's called in case there is an error. That's all that's happening there. And well, it's not actually unused because we're using it here. Oh, and your toke. There we go. Okay. Welcome back, Penguin. Sorry, one more question on the types. Arbitrary length integers, are they a thing? And if so, did you use them? Yes, that's what I just showed you. The U1 is... So, yes. So, this, you can have any arbitrary integer. This is like, well, maybe that was too much. Maybe there's probably like a limit to how many zeros you can have. There you go. There's the limit. Now, can you replace this with 9s? No. Okay, that works. When will this not work? Okay, let's do some binary search. Wait, it should be over here. Is it 6? Whoops. 5. Okay. Wait. Okay. So 4 works. Whoops. 9. Okay, wait. So 5, 0. $65, 535. Okay, so it's a U16, or yes. So you can have up to 65,535. Oh, not fixed length. You mean variable length? That's not what you asked, though. But arbitrary length integers. An variable length integer? I don't know. I don't think so. You can't change the type. Like, the type is... You can't, like, yeah. Well, you can. I guess you can cast to another type. But you can't, like, arbitrarily change it. A type is like, it's a constant. I'm not sure what you would use it for, like a variable length. Or, I mean, okay, do you mean that... So, okay, once a type has been constructed, you can't change it. But when you construct it, you can use comp-time known inputs. So you can make an integer type, like, let's say we have our my integer is going to be, there's like a, well, actually, I can just do @int. And here you can actually create an integer type based on stuff. So signedness, I guess you can say like, okay, let's say it's unsigned or signed, whatever. And here's the amount of bits, which goes up to U16. So that we already figured that out. So you can use comp time variables to figure out what types you want to have. So you can have a thing with 355 bits like this. You can define that as a number here and pass it in here. So I'm not sure if this is what you meant by variable length, because to me variable length kind of means mutable, but maybe you meant like this. It can depend on inputs given from comp time known stuff. Which also, I'm gonna show you another weird thing here. It's like let's say you have like my integer.txt, and then it's like I can say, okay, the size is 700 bits. Okay, so we can actually get that in comp time by saying my int txt is, and then we have embed file, which takes a relative path to the source file. So actually we need to store it. Okay, we actually need to store this in the source folder, because otherwise it's like outside of the folder. So I need to move this into source, and so whoops. So my int. So let's say this is 700. We load this in as an embed file. This is like a comp time function that returns a comp time constant. It reads in the file and spits out the string of the file, and then you can parse it. And that's what I'm doing actually in this compiler. I'm actually doing this to read in the source file of my game code, essentially. But then you get this, and now you have a string. And you can, instead of doing, well, actually bits, now we can do like format parse integer. Let's, yeah, it's a U16, because that's what we should consider. And then, and let's just catch unreachable here, because we know it should work. So now we have bits, which is a U16. Oh yeah, you need the actual, wait. Oh, you need base as well. Okay, base 10. So there we go. Now bits is read in. It's a U16. My int is now going to be 700 bits. And then we can say that this is my int here. And you are, well, we might have to put this as a comp time. Actually, that it should work. Invalid character. Really? Why do you get invalid character? Parse int. Okay, but in theory, you can do this. I just want to see what the hell is, what is going on there. Oh, is it the new line at the end? Why do we have a new line? There's no new line here. God damn it. But anyway, you could do, let's say we do, well, I'm just gonna clip off the last part there. So there we go. Now that should work. And now this is a U700. And to prove that this kind of works, let's set this to like U1. So now this should be a U1 here. And I set this to 1. That should still work. Okay. We set this to 2. Now we should get a compiler error. U1 cannot represent integer value 2. So if you want, you can, like with comp time, you can define your integer size in the file, read it in comp time here, parse it out through this parse function, construct the type, and then use the type. I'm not sure if you ever wanted to do it exactly like this, but you know, you could imagine what you could do with this. So it's actually really, really nice. All right. That is huge for comp time prepping, and that environment based on live logs to spawn into the environment. Well, you would have to compile it. But yes, I guess you could. You can base it on anything you want. And I mean, it's kind of like it's really like you can have this in any language using code generation, which is, I think, it's a really powerful tool that many people don't really realize maybe that they can use. But essentially, you just have some, like, you just extend your compile script or whatever to include a step where you compile, like, generate code based on some input data, and then you use that code in your actual project. And that pattern is like very underutilized, I feel like. I think it's because it's like, I don't know, it feels kind of unsafe and finicky maybe, but Zig makes that pattern more feasible, I guess. Yeah, so basically, if we go to main, I'm actually using embed file for my game dev DSL here. So this code is read in through comptime, and then I'm actually parsing it through comptime. I'm compiling it through comptime, and then runtime evaluates it. So so I'm tokenizing it, I'm parsing it through comptime. All this is happening in comptime. This is a comptime block here. So everything here is done when compiling this executable. So essentially, I'm kind of using the Zig compiler as a compiler for this language. I'm kind of building a compiler within the Zig compiler, you could say. So I'm kind of extending the Zig. You could say that we're extending the Zig compiler to be able to compile this new language. So then I'm just, when I compile the Zig here, the Zig executable here, I'm also compiling the actual game code, the actual game language as well. And then we have this evaluation stuff happening as well, because we get like an IR out that we can just step through and evaluate. So yeah. I just need to get to the point where I can like create a window and do some stuff there. But I needed some I need some kind of basic stuff working here first. But okay, let's get back to this. We have a bunch of like stuff happening here. So unable to resolve comptime value. Right, so you need to be marked as comptime. And you have a missing source. Let's bring in the source as well. Whoops. Basically, similar comptime my JS projects can factory build, closure, embedded checks, reading state will build live on init. Right. So this looks like a super easy version Zig offers. Yeah, it's really nice. I really enjoyed it. And I learned more. I learned, like, this is a totally new thing for me. Like, when I started Zig, like, in the beginning, I was, like, totally lost with this comptime stuff. And I just kept to, like, super basic things. But now I try to incorporate it more. And, okay, so I actually went through a couple of stages when it comes to comptime. So first, I was like, wow, this is really cool. And I just try to use it, and I just fail. And then I was like, okay, let's just give up and just try to use basic Zig. But then after a while, it's like, okay, well, now you see more of the standard library, you see more how they are using comptime and stuff. So then you kind of learn, like, okay, well, what if I do this? What if I do that? And then, oh, this works, and that doesn't work, and this works. And in the end, but then I was like, delved maybe too deep into it, and I was like, well, now it kind of feels like, well, the LSP doesn't understand the types anymore, so I just get a bunch of unknown everywhere, so it doesn't feel good anymore. So let's try to stay away from comptime stuff. But then, and then I go back to like basic Zig, but now I get kind of back to comptime again to try to find like a more, like a better way of using it essentially. And well, maybe a better way. Actually, this is kind of a different way of using it, because this is like actually using comp time to kind of just as normal code, essentially, as much as we can, and then now for this specific purpose to actually just extend the compiler to be able to compile another language, because I've never done that before, and it's actually really cool. And it gives you a couple of features that's not available in runtime Zig as well. You get like closures for free. Closures work now in comp time Zig. It doesn't work in runtime Zig. There's no closures in runtime Zig, but there's closures in comp time Zig, as long as you're working with like constant values and not mutable values. So that's really nice. It saves a lot of code. And other things as well. You don't need to allocate anything, and yeah, it feels like you're programming in like a parallel world. Now, after years of experience, what learning path would you recommend if my sole goal is maximizing comp time use? Kind of like what I said. It's like, I think that in the beginning you should kind of stay away from it and just learn Zig basics. And once you're comfortable with that, you can like explore. The standard library has a bunch of examples of how comp time can be used. So you can explore like the standard library. For example, the allocator. The allocator uses a this kind of uses like a, well, this isn't really comp time though. It's more like how to make a vtable based construct. So you can pass this allocator around. The allocator is kind of like an interface. It says to have standard memory allocation interface. And in Zig, an interface essentially just means that it's like a struct that wraps here a pointer. Well, this is one way of constructing the interface. There is another way as well. But it has a pointer to the underlying kind of implementation state. And it has a vtable which defines the implementation functions for that specific implementation. So these two are they are coupled because the pointer data needs to match the vtable implementation functions. And so here you have the different like implementation functions. And so yeah, you can go in and look at how they are doing things here. There's also, I would look at the other way of doing things in an interface is the writer in or reader. But this is another way to do an interface, the writer interface, which is simply essentially an interface to kind of write a bunch of bytes to somewhere. So you have a vtable, the same thing here. However, this has a bunch of other stuff, and it doesn't have a pointer because it's supposed to be a field. It's kind of complicated, but it's to explain here. But it's supposed to be a field of another struct that is the actual implementation instead. So that's another way to kind of create an interface thing here. And the reason why you would want to maybe do it like this is because you don't have to deal with any opaque anymore. You have writer instead. But yeah, anyway. So, but you still have to kind of assert that the type is correct. But yeah. But anyway, yeah. So I would just explore, look at what's happening. I mean, for me personally, it's just a bunch of practice, like to get your mind shaped to understand how to use comp time. You can also look at the array list, because that is like a very pretty simple way to use comp time. This is like the first way you would use comp time, essentially, if you would want to create your own type. It's just a function. So there's no real special thing here. It's just a function. But it takes a comp time type parameter. So, and then it returns a type. So this is what generics look like in Zig right now. It might actually change soon, but for the better. But I hope anyway. This is how you kind of make a generic. You can have types. Like type parameters are actually just normally defined like bindings here. So it's like you can have a comp time variable, which is a type. You can have a comp time variable. It can be anything else as well. But types are usually like they are only in comp time. There's no like you can't spill out a type into runtime. Well, that's not entirely true though, because I'm kind of doing that over here actually. When I'm logging out this, the AST actually has types on it. If we go to, for example, literal has it's a value. It has type as a field. But the thing is that the instance of this struct is like comp time known, so it knows, it kind of pre-populates, or when you print this out in runtime, the compiler will kind of use the comp time state to print the thing out. But anyway, enough of that shit. Okay. Yeah, so I would say just explore the different standard library stuff to see examples of how you can do stuff. Because the thing with Zig is that there's not a whole lot of documentation. Like there's the initial documentation that is available here. So you could go to ziglang.org/documentation, or just search Zig docs and you will find it. This has a bunch of information about everything with Zig, essentially, and you can like select your version or whatever. And I guess there would be some kind of comp time section somewhere, probably. Yeah, comp time. It's not a huge section, so there's not a whole lot of information here. But they do have a bunch of information, and they kind of show like how to do things here, what you can do. But there's a lot of things you can do with comp time. I mean, they could add a whole bunch of different things here, because I think they kind of leave out, for example, interfaces. They don't explain interfaces, even though it's part of the standard library. They don't really go over interfaces. I don't think we have list, which is super simple. Like it's just it's just like, here you have a list of super simple like a struct here. But there's a built-in in the standard library like array list, which is like a dynamic list. So and here you have like a node kind of showing that. Although this isn't generic though. Okay, it's just showing like recursiveness, I guess, that you can have a node that contains a node, except it's optional and it's a pointer. So if it wasn't a pointer, then this would have infinite size struct. But anyway, and then it's like print in Zig. This is also comp time. So the print function is like executed in comp time, except to like it produces like code that will produce the string based on like the types of the inputs. So it knows that this is a string, like a array or slice of U8s, for example. You specify S to say, hey, this should be printed like it's a list of things. So, but we specify S, so you need to print the elements as characters, essentially. And this one is just anything, like auto detect the type, essentially. They do go over. Actually, they do go over the writer implementation. Okay. Wait, they don't go over the writer. Wait, well, they have writer print. They don't show the whole thing, though. I think this is an old thing. Maybe. Well, whatever. They only show like a couple things here, I guess. Maybe. Yeah. Yeah, proof of concept implementation. I'm not sure if they go over like. No, they don't go over. You can do assembly as well if you want. Maybe we'll do some assembly in between here. Like Raylib assembly with FASM. Or zig. I mean, you can do assembly with zig. We can even... no. I mean, zig has like some kind of assembler built in, I think. Somewhere. C, C++. Maybe not. I'm not sure what these are, like RC, ranlib. I don't know what these are. Well, you can dump to assembly code. Okay, maybe I was wrong, but it does have you know, C++. I didn't know about C++ actually. Wait, where's the dump? I'm pretty sure there was like a way to produce just the IR code or like in between. Okay, well, anyway. Regarding assembly part, I was wondering what the targets. It depends. It can target like everything in the universe essentially. Look at the target list. Actually, you know what? You can actually generate the targets here. Here's all the architectures. These are, I think, CPU architectures. You have operating systems, different ABIs. You have different like versions of libc or something. I don't know. glibc. Here's the CPUs. Yeah, so there's a lot of targets. Like this file is 32,000 lines long. That's all your like. I don't know if everything is like supported, but those are the targets that you can specify. So yeah, I don't know if everything is like 100% supported, but yeah. Where were we? Okay, we had some. Was there any issues left? Right. Okay, so we're over here. We need the source. That's just context source. We could make a convenience though. We could just take some of these because source. We don't need to pass in source. We can pass in the token, potentially. Yeah. So report. Let's get comp_time format string args. Let's get the token. I think that's it. And the no. And the level, right? Level. And this would just be report. Well, self.report, and then init source level format args from token source token. And oops. I would only need to targets WebAssembly Cosmopolitan libc. But it's obvious now zig+raylib builds nearest get to hardware is present. Yeah. I mean Zig compiles to native, yes, and also WebAssembly, so it's you can do both. Expected type. Right failed. It's a different error? Come on. Set color error. What? I mean, I guess, yeah, it works on Windows as well. I guess that's good. Okay. But why can it be a cancelable? Is that like... What's happening here? Unexpected status. Operate. Is it this because of this one? Operate. What the hell is going on here? Man, Windows, why are you so like, why are you like you are? I mean, okay, let's just do catch error, catch return. Actually, you know what? If this fails, I'm just gonna not care, actually. There we go. It's not that important to have colors. Unable to resolve comp time value. Okay, so that's like the two things we have now. Item self. I guess if we mark you as comp time, will that work? Excuse me? Okay, if mark that as comp time works. So you have to kind of wiggle your way through the comp time stuff sometimes. Unable to resolve comp time value. Like in theory, I know what could work and not could work, but then you don't know. Okay, what is actually like implemented in Zig and what works and what doesn't work. In the details, it's like you have a plan, like you have like an overview plan to like, well, this should work if we do it, but then you go to the details and it's like you get stuck on like a stupid detail somewhere. It's like, oh man, if only we could do this, then we could do all this. But this one, I guess, I mean, wait, is it because this is not comp time or what? Comp time T. I mean, okay, that seems to work. Great. We run this. And there we go. Oh, we got 2 errors reported. Okay, so this is now maybe an example of also like how much it says error here. This might be like an example of, you know, we have multiple errors reported for some reason. Not sure why. But it says unexpected expression, and it's gonna be this line over here. Oh yeah, also, we don't actually report, like show surrounding lines, which was one of the things that we wanted to do. So if we go to parser 2, and we go to the diagnostic stuff. Right, so the span has a start line, end line, index. The thing though is that we do not pick the previous lines when creating this here. I guess it, like, what we could do is just, it's gonna depend on this here. So we have like start end, but then we would like to include previous lines as well. So this is like I'm gonna call this the span start, span end. Now to get the previous line, we probably just need to like do span start -1. And this would be like start end. So start would be, well, if span start is 0, it's just going to be span start. Otherwise, it's going to be span start -1. You know what? If span start is 0, it's just going to be 0. Otherwise, we're going to do find line column of source and then span start -1. And we want to get the, I guess it's gonna be like source line length minus the column. So let's do like end lines extra. Let's do like 2. We'll do like var start is span start. I'll do 4 end lines extra. We're gonna say start is negative equal 1. And since it's a unsigned, we need to guard it for underflow or whatever it's called. And then we are going to say that we need a location. It's going to be standard zig find line column source byte offset is start. So we're going to find this line. And we are going to say that now the new start is going to be location source line length. Wait. No, we know that start is at the end. So we could just say that this is negative equals location column. That brings us back to the start of the column. Okay, so that is our new start. And the next iteration, so now we got a new line in place. And then next iteration, we'll go back once more to try to fetch the next new line in the same way. And I'm going to the same way for end, except this needs to be +1. However, we probably don't need to guard it. Whatever, let's guard it anyway. Because it's a U size, so it won't like go over. Well, whatever. The problem here with end, though, is that what if it's more than the source? See here, there's no guard for that, so it's just gonna crash. So we have to check here if end is within the source length. So this would be min end and source length. Okay. So there we go. Now start and end should be like, you know, appended there. End is unidentified. Location. Sure, let's just reuse that. Success. And that doesn't look good. Okay. So it just added 2 to end. Huh. Oh, wait. End. No, okay. So what is column here? Column should be like 0. So end is just it's just 0. What it really should be is the source line length. Or -1. I don't know, but yeah, there we go. Now we get the whole thing. And since we don't have, crucially, since we don't have more lines, it's not going to show more lines. But let's go and test some more stuff here. I'm just gonna repeat this a couple of times, and then here I'll do like, I don't know, a couple of ones. Let's do like this so we can see different things. And I don't know, let's actually continue the trend so we can actually see the difference as well. Okay, so if we do this now, we get an error. Okay. Interesting. Oh, validation exceeded 1,000 backward branches. So yeah, this could be the issue when doing comp time stuff. It's like, it doesn't allow you to run comp time forever. So the default setting is to say 1,000 backwards branches. You can change this. So if we go to main compile time, when we start compile time thing, we can set eval branch quota to be, I don't know, 10,000 or something. So there we go. Now it works. And we see now that the error is on this line. Well, we don't see it actually, because it doesn't really show here. But it should be on that line. And then we can see that we have 2 lines before and 2 lines after. So that actually works. Nice. But why is it... Why is it not parsing? Like, why is it not color? Because start line and end line... No, we passed that in here. Yeah. Oh wait, it's not relative, right? It's not relative to the thing. So index, so it will never be within the start line, end line, because... And it was before, because we started at 0, so it was relative then. It happened to be relative, but it's not relative now. Okay, so this actually needs to be relative to where we start. So actually start line is going to be depending on how many lines we got extra here. We don't actually know that from this data here. Unless we count somehow that we could do start line is, let's start at 0 and end line's also 0. And then here we will say start line equals to lock line, because that is the new start line. And then here end line is equal to lock line. That is the new line. And then over here we can use start line and end line. So those are now relative there. Actually, no, they're not. It's gonna be negative. Wait, no, it's gonna be start, span start line. No, self start line minus that. So if this is 10 and this is 9, it's gonna be 1, yes. And then we do the same thing here. This is end line. And you are U size. Oh. Integer overflow, expected integer overflow? Oh, right, they can't be U size, they have to be I size because they're relative. Okay, let's make them I size instead. Sure. Unless we just say which line we start on. No, let's just make them I size, whatever. And you are U size minus U size. So the thing is here, we need to like cast this as an I size first, and then do that. Do we need to cast both of them to I size? Oh my god. Well, if we set this first to start line, and then we just do negative equals lock line, will that work? It doesn't fit though, does it? But we can cast it. It will never really crash here. Yeah, okay, let's do that. It looks a bit weird, but whatever. End line. I feel like I missed something. No? Okay. No, it still doesn't work. So if this is 10, now this should be 9, so this will be 1. And next time it's gonna be 1 more, yeah? And if this is 10, and now this is 11, this would be -1. No, that doesn't work. It has to be from the start. Yeah, I think. No? So if this is 10, now this is 11. No, that's the same thing. Is it gonna be plus equals? No, it's not. Or do we start with lock line and then negative start or end? No, it has to be start. Yeah. So we start with lock line and we do negative start line. So now this is 10. This is gonna be 11. That's gonna be 1. Yeah. Wait, am I doing this correctly? These denote where the span is, right? Yes. So if I include more code, I need to specify where the span actually starts and ends. Yes, that is correct. So if we say, I think start line is correct. It's like end line. Actually, end line just needs to be start line plus the actual. Yeah, we don't actually need to do stuff with the end line, I think. We just need to set end line after here to be start line plus line, like the actual number of lines that we have. Okay, there we go. All right. Okay, so there's an error on this line. Unexpected, expected an expression. And it's like, yeah, okay. But it's showing the line, but it's not showing the place where we had the error. So what I'm gonna do is I'm going to now in the snapshot, like remove all the diagnostics that came to be. So basically, because you can only ever add diagnostics, we can store the diagnostics index, like the length of the diagnostics, and when we restore the snapshot, we just need to kind of set diagnostics to be. We just cut off the rest of the diagnostics. I feel like So let's save diagnostics, just number of the diagnostics. The LSP is having a real hard time figure things out. So this is just the length of the diagnostics as it is right now. And then here we'll simply reassign you to be diagnostics 0 to diagnostics n. So that will just restore that. So yeah, man, doing things in Contime is like super easy compared to like some things are super easy, I would say. Okay, man, I really need to switch over to the other projects in there. But yeah, anyway, so that's the snapshot restoring that. So now this should have an effect already. Perhaps. Yeah, now we only get one error. And it shows something there. Now the thing is, if we have span, let's also possibly say the thing about here is like we should have like, let's say if line index is like we start at start line, we will add one each line, and now we want to check if we are at the start line. We want to do one thing, otherwise we might be on the end line. We want to do something, otherwise we are at the actual, like the whole line is like part of the thing. So I'm gonna do this. If we are at the start line, what I want to do is I don't want to highlight the whole line. I just want to highlight the part where the column that starts. So the first part is going to be line source line 0 to span start column. That's the left part, and then the right part is the rest. So that's gonna be column to the rest, and that the right part is the one, is the part that we actually want to highlight. And then we can keep the new line. This part we can remove. We can print the start without the new line, and that's the left part. Okay, so that's how we want to do it for the start line. And then for the end line, we can also have a left part and end part, but this is now the end column instead. And we want to write the left part highlighted, but the right part not highlighted. And actually, even I probably want to keep this thing outside of, yeah, let's just do this like colorless. Actually, then we could just generalize that. Actually. So now at the end line, we want to write the left part with highlight and the right part with not highlight. Okay. Because that's going to highlight the actual... It still highlights the whole line. I guess another case is if they are equal, like yeah, another case if the span start line and the span end line are the same. That's actually another case. Because then we kind of have three parts. We have the middle part as well. And so this would be start column to end column. And then you would be end column. And the left part we print outside. The middle part we print highlighted. And the right part we print like that. Right. And okay, and now we see that it's this token that we're talking about. Okay, cool. So we can kind of see now a little bit more clarity on what's happening here. But it's just unexpected expression. So it's like, yeah, we still don't really see what the issue is. Let's go to it's like binding identifier number literal. So it's supposed to try a binding. And I guess you know what? I want to make like a simple handler as well. Simple error handler. Format. Let's actually just have a simple message. This gives us an error handler. I think token and then parse error. Void. Actually, we need that. No. You take a token and error and we report. I mean, technically we could show the error as well. But this just throws in the message there. And so this one is just, we could just do simple error handler. So we don't have to kind of, you know, define a function every time. We could just use this now to, actually I could move that into core perhaps, actually. Yeah. So now instead of defining handler each time, we could just use that. Pretty simple. Yes, right. You need to be comp time. That's right. That was the issue. And then you are actually comp time here. We should have the same thing happening. Yep. Okay. We can even simplify this even further. We can have a handle error simple, which is we produce a message, and then we also get the parser. Actually, let's put the message after, and then we get parser payload of parser. And this will be return handle error of parser with a simple error handler with the message. And now we can change you to simple. And instead of passing all this, we can simply put a message there. So that's a little bit easier to define there. Okay. This one, well, we could do handle parser here, I guess. Handle error simple, expected number literal. Do we get this error message? I'm curious, because it is kind of the last thing that would, no, because it's gonna try parse. The thing about one-off is also, like, how do you decide which error to show? That is something I've been grappling with for a long time, with these parser combinators. I haven't really looked up what a good way to do it is, but I usually do it like this. So basically, so the whole issue is that if you have a one-off, it's gonna try a bunch of parsers. Probably easier if I show this actual thing here, parse expression. So here we have one-off. So it's gonna try all these parsers, right? If this fails, it's gonna report an error. However, we're rolling it back. So it's gonna try the next one, but we're rolling that back as well if it fails. And if this fails, we're also rolling it back. So in the end, all of these will roll back. The error that we get is gonna be this error here, right? The problem is that we probably wanna show an error from within to know more about what actually went wrong, because it could, like, for example, parse binding, it could have succeeded with const and identifier and equal, and maybe something went wrong in parse expression. Then we probably want to show that error instead of showing this error here, which doesn't really have any information in it. So the way that I usually do this, I try to have a kind of parsing, I believe I have like a parsing depth variable, which kind of says that, okay, how deep do we get in the parsing kind of structure when we get this error. And I pick the error that was reported that has the highest amount of depth to it, which we could potentially show in perhaps the diagnostic, maybe, or the error somehow itself. well, the error itself, this can't carry any payloads, but yeah, somehow it could be the context, the parse context actually has like a depth, current depth here, starts at 0, and then whenever something is, whenever we like do something that will increase depth, that is now like taking priority essentially. The question is, where should that happen? How should it happen? We also need to remove depth if something goes wrong. So this should be also part of the snapshot as well. So the snapshot should have the depth as well, and we need to restore that here. All right. And then the thing is, well, maybe not in diagnostic, we don't have depth, or maybe we do. Maybe we do have depth. Maybe we gather all the diagnostics anyway, and then just pick the one that has the highest depth. To show. Although the problem is sometimes you do want to show multiple errors. So how do you decide what errors to show? Maybe if they are on... Maybe... man, this is so difficult. I guess it might depend, maybe? I don't know. We also could just not... No, because the problem is, like, if we don't remove diagnostics that was added, the problem is, in a one-off, if it ran through some stuff that added diagnostics that failed, but then found one that didn't fail, then we don't want those diagnostics in the context anymore. We want to remove those diagnostics because those are actually false errors, false alarms. So I guess it could be like in here, we could like have a snapshot. Perhaps. Hang on. No, I lost it. I lost it. I got distracted here because I was looking at this, a bunch of try keywords. I mean, we could start out, but just not removing diagnostics, I guess. But we will get false alarms, though. That's the problem. I guess if we go through here and all of the things fail, then we don't... We try to gather all the diagnostics, maybe. Maybe try parse actually returns like a snapshot. Like if it fails, we restore the thing, but we also take a snapshot of the later one. No, that doesn't work because we can't restore the diagnostics. So actually, maybe we don't want to have try parse doing that here. but we do though. What if try_parse returned a tuple of like added diagnostics? We can, because the snapshot it could have like diagnostics diff, added diagnostics. Why would we need that though? We want to keep everything before we want to keep. No, this doesn't make sense. All right, I'll just go and fetch coffee here. Be right back. All right. Okay, maybe I'll leave this for now a little bit. I could look at how we're doing it runic, because I believe that one has a pretty good way of doing it. I just can't. I'm pretty sure, like, because we have like in runic, I think we have like custom snapshot handlers for each of these kind of primitives constructs, and it works quite well. I have yet to actually test out bind actually. So for example, okay, let's say, so bind, for example, could determine the outcome. Let's say you have, okay, let's go to parse expression. Let's say, so here we have a bunch of different things, right? So with bind, we can actually get rid of one off, to be honest. you can kind of use bind as a way to kind of say, well, if we parse this thing first, then we have these possibilities. So for example, let's say we have like a parse discard. This would be just a token discard, or is it like underscore? No. Discard. What is it? What is that called then? What? Or is it part of an identifier? Wait. Yeah. Okay, so it's like an identifier, but the identifier is an underscore. Okay. I see. So it has to be an identifier. So basically parse identifier, but it's only okay, now we can use bind actually, because we can do, okay, so let's do bind on identifier, and then we want to do like parse discard bind. So what this is gonna take is we're gonna take the identifier payload, and then it's going to, yeah, that's it actually, but then it's going to return a new parser. So we're returning a parser which has to, well, it can have any type actually. Well, I guess it's just a node. Yeah. Which, well, we don't really have a discard node yet, but I'm gonna just use identifier. So essentially it's just gonna be the same. So what we do here is we just say, okay, now we can compare the actual identifier string to underscore. So if this is equal, then we will return identifier. Oh yeah. Wait, this returns a parser. Yeah, so this is kind of like a continuation here, actually. We return a parser. The thing is, like, we can just do core pure. Yeah, this is kind of like returning a value into the node. So it's kind of like a map, actually, here. But I will show you what else it can do. So this would just be a pure map here. Because we're mapping the identifier to an identifier node. So this would be an identifier node. No, we don't actually get. You know what? Pure can be defined on the actual parser, to be honest. As well. Because then we could just do dot pure. So this is pure. It's gonna return well, it's actually we could just do this. Const pure equals core.pure. Where core is this. And this refers to that. There we go. Because this is a constructor. So I should be able to say dot pure. No? Okay, so it's not actually this. Fine. Let's define it here then. This is going to be type of t, and or it's going to be this actually. Value is t. This is just t. We return value. Okay, that is pure. And if we go to the other pure, you can actually just say dot pure value now, because that's going to be implemented over there. Now the reason why you want this both outside and here is because this one is like generic. It can take any value, make it like any payload, and make a new parser type out of that type and use that pure function. Unlike this pure function, which is like, this is used if you know that you need a parser of a certain type, you can do dot pure now. So instead of, so this now we can say dot pure to give us the identifier there, and now we get like all kinds of nice LSP stuff happening there. Nice. Okay, so but as I said, as we're doing here, this is just a normal map. However, if we don't get the proper discard identifier, this is going to be an error. But we can't, but there's no error here. So how do we return an error? Well, we can actually have a error construct for that as well. So let's say we have error here, and let's pass in some kind of error. Well, this is going to be a parse error actually. Yeah. So we have an error, parse error. It's gonna bring us a parser. We have an error function. And this is gonna return the error that we have. So essentially, it's the same as pure. Actually, it's kind of the same as pure actually. You know what? It's actually just pure. However, the difference is that this takes the payload, and this takes an error. So I guess we can have one implementation that's private that has like pure or error. And this, oops, return value, type of value. And then these don't need special things. It's just going to be pure or error. Value. There we go. So now we can say here, we can say .err. Okay, so if this happens, then we want an error happening. And the error is like, I don't know. Unexpected expression, unexpected token or something, I don't know. not supported, let's say. No. Unexpected token, let's say. I don't know. Expected discard found something else. Okay, so we kind of defined, this is how bind works, is like you can look at the payload of a monadic value, and then you return a new monadic value depending on what you want to do. If you just want to return a new payload, it's kind of like map. You use pure. But if you want to change you could change the parser course entirely through bind, depending on the payload that you get. So this is a really powerful way to do things. And we can also like wrap this in handle error, I think, if we want, as well. So we could do like handle error simple. The problem though is now we can't use .er anymore. Yeah, that's the issue here. It's like it doesn't understand that this actually, you know, it doesn't understand what we need here. So that's the issue here. So in order to fix this, you can just do parser node. We have to spell it out. That's the only difference here. And then the error would be expected discard. Cool. And then let's say we parse a discard before identifier, because we want to try that first, since they share kind of the token type. Because if we parse identifier first and that succeeds, it can still be a discard token or discard identifier because it just accepts all identifiers. While this one is more constrictive. So we're going to run this first to test if we actually get a discard identifier. And then test that. Okay. And now, where are we at with this one? Okay, so we're still at here. And let's try now. Well, yeah. So, I mean, this kind of proves sort of that, you know, we're not running the discard code, I guess, but we are. It is part of the code path that it's part of, you know, this function which is getting called. So it should work. Now, another thing that you can do is like you can parse an identifier and bind it to, you know, parse identifier in expression handler or something. Like that path can be taken. Instead of having a one-off, we would first, like, I guess it would be more of an imperative pattern where you take the next token, switch on it, based on what it is, you return different parsers. So now we're back to imperative again. But the crucial difference is now we're in monadic land, so we don't have to pass the context around everywhere. We don't have to deal with that. We can do cool stuff. Man, I wonder if this would work in, like, if bind would work in runtime. I think it does. It's just that we have to deal with anytypes. Although, what if you don't care that it's running comp time? We could use a comp time monadic structure to kind of you know, create the code. Like that's what's happening now anyways. Actually, no, everything is running code time here, but what if you would produce code from the monadic comp time stuff? Okay, well, the time is 12:16 here, so I think it's time to switch over to the RPG. But yeah, I'm not sure how much, we didn't do much progress. I mean, we added like diagnostics and stuff. But, and I don't really know why we get this error here. Like why we get an error. Let's do this. In the diagnostic, I want to store which depth did this diagnostic happen at. Oops. And where is that report? And this is just going to be self depth. Okay, so we're storing when it happened, like which depth, at which depth did it happen. Oh yeah, in Runic I also have like a breadcrumbs, and that is really easy to see. With the breadcrumbs, it's really easy to see like which path the parser takes. I don't have that now. That would actually be yeah. Let's add a to-do here. I'm gonna maybe do this off stream later, but add breadcrumbs. Yeah, because that makes it super easy to kind of see what path do we take, where did we end up, where did it go wrong, where do we like create a snapshot, where do we restore it and stuff. So we can even have maybe kind of like a log of what's happening as well. Maybe we'll store like a log as well instead of breadcrumbs. Because the breadcrumbs is kind of like a tree-like structure. Maybe slash like or log. Yeah, I don't know. Like if we would just have a log, I'll just keep going. Then okay, yeah, a log, something gets reported. Log message item yeah, so we have the log. Log message. The thing about the message though, we probably want to also have we want to have the indentation. It's going to be a space times the depth. So indentation plus message. Wait, we don't need to do all this. There we go. One argument found too. Oh. I added it to the wrong place. There we go. Cool. Okay. Okay. Yeah, so when a diagnostic is reported, we will log it as well. So log diagnostic reported. And I guess we can show the message. Well, we can just show the whole diagnostic, to be honest. Oh. Yeah. And this is, yeah. This would really be good with formatting, so message, this is gonna be, okay, so message is comp time print, format args. There we go. Cool, so now we have a log where, well, simply everything that is reported is gonna be shown in the log right now. I guess with indentation, but we don't have anything that actually increases depth and stuff like that. So we have to kind of decide, okay, what should increase depth and what should not increase depth. I guess potentially one-off might increase depth. I don't remember exactly what kind of things I would use in Runic for that, like to determine that. But I think it was the primitives. The primitives here were like one-off is I would consider like a primitive, or a sequence is like a primitive. So let's say one-off, for example, let's say that this increases the depth. So we'll increase depth by 1. And then we'll do a bunch of try parse. I guess if we... I guess, yeah. So we have a snapshot. We increase the depth. If something goes right, we return the thing. And now we need to actually decrease depth again, because now we're out of that. I guess it's the same thing here. So I will, so this is the, in case of success, we will decrease depth and return the result. So then we're back to where we were. We should always, it should always go back to 0. It should be a balance. Otherwise we're down here. We get an error. Actually, do we even need a snapshot? I don't think we do. No. We don't want to have a snapshot. We just want to... Or do we? Now let's just do this. Okay. Because, yeah, the snapshot will revert the index of the tokenizer, so we don't want to do that. Yeah. So one-off will increase depth. Yes. And we can also log that we are in one-off as well. So we can log one-off. And then we could potentially pass in like the parsers somehow, like if they have labels, I think this is what we do in the other thing. It's like a parser can have a label. For example. Yeah, I mean, actually pretty simple here, because this just needs to be a label, and we just pass in a label alongside with the function. Yeah. And then down here, we can do like one of, and then it's like in parentheses, well, we need like a list of, well, we could do, no. There's no like comp time writer, that's the thing. It would be nice if we had a comp time writer, we could write to a string in comp time. I mean, I could actually just make one, I guess. Oh my god, I'm just dragging this out, but this is so interesting to me. Comp time writer. So yeah, this thing will essentially, it will have a, it's not really a buffer, it's more like a result, or the actual written starts out empty, return, or I mean function init gives us this. Okay, and then we could just have like print, which takes comp time format string, no, and args, and then it takes self is this, and void, and we, yeah, let's just do void. And then here we're gonna say like written is equal to self-written plus comp time print format args. Super simple, actually, because of comp time print. Comp time print is amazing. It's actually pretty simple. It's just a buff print wrapper in comp time, but yeah, it's really nice to have. And then yeah, and that's it. And then let's have like, I don't know, we could also have like write all. There's like a couple of different like function, like methods here that we can implement, but this is gonna be plus s essentially. Yeah, and then you get written is the actual string that we get. So now we have a comp time writer. We can, that was actually pretty simple. So basically we're gonna have like the labels is, let's do like comp time writer, and we're gonna do like 4 parsers, parser, we're gonna do labels, print, parser label, and then this is going to be the labels dot written. Okay, let's go to main 2. So if, yeah, let's also put out the logs, or the log, whatever, context log, and here compiler diagnostics. Let's also go through the log. Oh, right. Okay. And this is just a string. All right. Right. So now all of these actually need a label as well, which is actually pretty simple to add. Because, you know, it's all these init functions. We could just do this. Another thing that I would like to do, instead of saying one off, I'm gonna say source function name, because that is an easier way of saying that. And also, to be fair, we could also actually just append labels written in here, but that doesn't really matter. Token expected to organize around one. Right, so this is now token. Okay. This one is get context. This one is sequence. Map. Actually, you know what? We could just use function name. Why not? Oh, except here, I guess. We can't do it there. All right, parse number literal. Well, let's use this so it's like consistent, I think. Yeah. Let's go for some consistency. Parse expression. Yeah. Handle error. Okay, so handle error. The question is, no, this should just have the label there. Yeah. Yeah, this is just source name or source function name. Yeah. Okay. Oh yeah, I guess this is a var. Try parse. Okay. Oops. Okay. We get like all of these. That's the thing also. Yeah. So I did this in the other thing. It's like a kind of, you can kind of define label boundaries. So it's like, if we don't have a label, then, or if we deem it like unnecessary, I guess transparent, it will get whatever label was. It's like inherits the label or something like that. We could probably, because now it's like, okay, it's one of map, bind, map, handle. What you could do is if we go to, for example, parse expressions, no, not parse expression, it's going to be parse expression here. Yeah, these are the things. So binding, discard, identifier is probably those ones that it's saying here. Map, bind, yeah. So discard is bind, because we're just using bind. We're not actually labeling this. So what we could do is we could just introduce a label here that we say that this will be the parse discard, for example. And now that should be like labeled as parse discard. Yeah, so that's a better thing. So we could do that. And let's just add label takes a label string, and it takes the parser, and we return the same parser, except we change the label. The question is, do we just set the label on the parser, or do we create an entirely new? Let's just create a new, I guess we create a new label, a new parser. Yeah, then we're kind of transforming the label of the parser. We're not binding it. I mean, I guess we could bind. No, because then if we bind it, we're now back to the same issue. Yeah, so essentially we have to create a new thing with a function. Yeah. Okay, sure. Let's just do that. Return parser run context. Okay, so it's essentially just a wrapper. It's just a wrapper around, and then the label is here. I'm contemplating whether to change the order of those. Whoops. But yeah, now we can relabel a parser. We're basically wrapping it in a parser does nothing, and just having another label on there. So this will now label this as parse discard. So if we run this again, we should see parse discard there. Yeah, so now we see parse discard here instead of like bind. Cool. And I'm getting a lot of these one-offs. I mean, yeah, sure, because we have a lot of lines of code, right? Let's get rid of all these lines of code. That was just a test to see. Yeah. So now we only have like these things. Okay. Okay, so here we go already. We have diagnostic reported, unexpected number literal, or expected number literal, when it got a minus there. Which is interesting, because or it expected an expression, or wait. Well, okay, whatever. Let's not analyze that further. I just add a little bit more, and then we'll switch here, because I do want to get some progress done on the game as well. But this is so fun. This is fun, Ruffle. This is fun. Let's create another universe. Yeah. Okay, so that was parse discard. Here's number literal. Parse number literal. We already have a label for that, although we do have handle error as well. Do you have function name? You don't. What is attributes? It's like call convention and stuff. Okay. Yeah, so we have to kind of label the whole thing. So if we could make this, yeah, this is gonna look weird. It's like we have parse number literal, and then we have handles error simple outside of that. So maybe if we had like init with error handler, we could also do, I mean, this is the only try we have really. So if we just catch this, wait. Hang on. I think I know what the issue is as well. No, I don't actually, because we don't know. No, we don't know. We don't know. We don't know. No, actually, I don't know. I have to. Okay, so an easy fix is just to wrap this again. But the long-term solution would be to rewrite this in monadic form, and then because then we can wrap that in handler simple, and then wrap that in a label. But I'm just gonna wrap this in a label here. So this is parse number literal. I guess this would be the inner. We'll call this the inner one. Parse identifier. Same thing here. I'm gonna label this as parse identifier S. Here we have parse identifier, parse binding. I forgot about the string up there. Okay. Are we missing anything? Parse discard. I don't think so. The main parser, we could also label main parser if we want. Cool. And if something is labeled, I guess also we probably want to log as well. So we can just log here. We can log like, yeah, this is the label. And we are currently running things under this. So maybe even we could increase depth as well. Yeah. What? It is comp time. It is comp time now. Okay, let's use comp_time print or comp_time writer, and for depth print or write all and will be rewritten. Expected loop payload, right? Comp time. It's not runtime though. Everything here is comp time. Let's just wrap everything in comp time. What? Wait, can I say comp time here? I don't understand. Oh, hang on. I think you have to use inline? No? God damn it. Yeah, this is sometimes the quirkiness of comp time you have to deal with. Wait, now it works. Okay, so I solved it. Cool. I get a seg_v. Okay. So if you mess around in comp time too much, you get a seg fault while compiling. I guess because this is mutable, perhaps? It should have detected that if that was an issue. So indentation string, indentation written. No. Can we now use, like, for example, if we say this, will that work now? Did I all do that all? Wait, it might be something else that's the issue. Yeah, this doesn't feel like a seg_v thing. Okay, that interesting. Yeah. So if we don't call if we don't call this, do we get no? So this causes a seg_v here, seg fault. Is it this? It feels strange that that would be the issue. No? Wait. No, it still gets... Okay. So something about calling it here will... Maybe it's the label. Sometimes it has... Wait, shouldn't this be just label, actually? Like this? Yeah. That should be the label. But it still is an issue for some reason here. What if we just pass in label as a string? Probably won't work in a way. No. Strange. Because it does work from the one-off. But something about this doesn't work. I mean, it might be a compiler bug that I'm looking at. That's a shame. And right, and the snapshot should not deal with the log. Yeah. The snapshot, the log should be persistent throughout. Because it's like a full-on debug thing. Okay. Interesting. Okay, well, I hit a roadblock. So let's switch. Let's switch it up. Well, this is Runic. I'm currently discussing with Claude here to how to proceed with Runic. One second here. I'm gonna check. Okay. Anyway, Yeah, we're currently discussing it, but I won't go into this right now. Maybe I'll just skim through here because I do want it to kind of work in between in the meantime. Clean, blah 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 blah. Foundation fix, yes. Comp time. So I want comp time in Runic. Yeah. Let's see if AI can fix that for us. Continue infer the call site. What the hell are we talking about? Generic functions, monomorphization, performance, function can apply tolerance, compile inference, and call. Generates a special copy per type of combinations of function, blah blah blah. Infer the call site. So are you saying that we don't have to define them? It's kind of like Haskell. I like it. I really like it. I think this is kind of what Zig is gonna move towards as well, except it's gonna be a slightly different syntax, but you're gonna be able to kind of bind variables into like basically like pattern matches like this, which is gonna be incredible if that's the way they're going. I think I saw a proposal for that was in the works, but yeah, that's gonna be insane. Stage 2 type returning functions. Sometimes Scooby-Doo. Returns a type, and we will yield a struct. Yes. And you can stream your types. Okay, so const int box int. Yep. Arrays already exist. The shallow standard doesn't need stage 2 is deferrable. Arrays exist. Yes, they do. Stage 3 fuller comp time values, computer comp time. Type of comp time branching on types, etc. Out of scope, shallow, grouse as needed. Key design fork is wait. Key design fork is how stage 1 type parameters are written, because it determines whether stage 1 needs the full complete type machinery up front or can ship a lighter step first. Okay, let me do this. How should a generic function's type parameters be written in stage 1? So we have just implicit variables. I really like implicit variables. Explicit comp time variables. Then, I mean, what if you could put constraints on them like this? Like, because you could potentially have type classes. I don't know if we want to go there, but you could put constraints on these. So basically you have like comp time t type. Okay. So here it's simply, you know, it can be anything. But here it's like, well, now we can potentially put constraints on them through some kind of syntax. Implicit now comp time desugared. Desugars to comp time tu. Type internally. Yeah. Sure. What would this be though? No comp time key keyword needed. Desugar containers reuse same comp time engine. I guess one is like what it like recommends, maybe. Not sure actually. I would rather have the ability to actually provide it or choose to. So let's do that. Okay, so it's churning away. Cool. Anyway, let's start with the dungeon crawler, except I'm gonna need to take a break. I'm just gonna eat some food and I'll be back in like, I don't know, 5 minutes or something like that. So be right back. All right. Let's continue. Well, actually, I'm gonna eat a little bit. So you're gonna have to watch me eat or do something else. I guess it's kind of hard to tell whose turn is next. If you're twice as fast as someone else, and well, especially if they don't move every turn, if they are idle, then it's kind of hard to tell whenever they have made their move. I guess that could be part of the game, I guess. It's like now I know that the goblin actually made their move there. So if I try to time it, okay, now I can go in without being damaged first. Although it doesn't actually matter at this point because of the timings. Actually, I did take 2 damage, so it does matter. It does matter. So now it moves, so we can move in, get a damage in, get a damage from them, and then we do 2 damage. Yeah, because otherwise we take 1, deal 2, take 1, deal 1. Yeah. Can you slow the rendering? Yes, I can. I just lower the FPS. You set the FPS to like 10. And what this is doing essentially is just Raylib will call the update function less. Yeah, you have to wait for the whole animation to play out. Just wondering if it is separate or coupled to the frame rate. Yeah, the timing is kind of, it is, okay, so I do have like physics FPS, which is kind of part of the physics system. But the physics system is like, I think it doesn't matter now because it's still limited to one frame, one physics, like you can't run multiple physics frames per frame, so to speak. If we were to, so as long, if your FPS is lower than the physics FPS, everything will slow down. But if it's higher, I believe that it won't be faster now. So this should not be faster than 60 FPS, as you can tell here. So if I change this back to 60, that's gonna have the same speed. Yeah. So, but if we go lower, and the reason why it's not kind of try to show the same speed is basically because I don't want to, well, in order to keep the same kind of physics precision, you still have to do the same simulation. But let's say it starts to lag because of because you take up too much computer resources time. Then if you start to try to catch up on the physics, like you try to run multiple physics frames just to try to catch up, then it's that's gonna lag more and more, and you're gonna get like slow to crawl. What happens when you lower the physics FPS? Well, then the kind of world simulation will get slower. So if I raise this to 60 and I lower this to 10, everything will be slower as well. Or not. Wait, that doesn't make sense. So this is kind of the mechanism for calculating like the time, the simulated time. If we're paused, we don't want to do anything. Otherwise, we have the physics time step, which is essentially just going to be like, if the physics FPS is 60, that's going to be 16 milliseconds. So 0.016 in this case. Or, well, 16.7 more accurately. 60.6 repeating. Delta time is like real data time. So we're trying to see like, okay, how much delta time has passed in real life. But and then we have like elapsed time. This elapsed time is like how much time has been simulated. And then there's some calculations being done to try to keep this correct here. Well, the physics FPS should also determine... No, actually, no, that's true. Because if physics FPS gets low to 10, that means 10 frames per second. So time step would be 10... Actually, 100 milliseconds. Okay, so that's why it doesn't go slower. It just lower resolution. Yeah, it's just lower precision. which depends on, like, it kind of depends on what kind of units or scale, what kind of scale you're working with, and what kind of, you know, scale of velocities and accelerations you're working with. Because it's going to be hard to kind of make sure that... Yeah, we have to make sure that we're always staying on... Because the thing is, I don't think we even use acceleration or velocity in this, but in other like versions of this engine, I do use like velocity and acceleration and stuff like that. But in this engine, I don't really use that, just because, or in this game, I mean, because everything is like pixel based. Like, it doesn't make sense to have like floating point velocities and stuff like that. Let me just allow this to go through. All right. So actually, I'm still thinking through all the stuff to see what makes sense to comp time. Well, this isn't comp time. This is runtime. In any case, scanning the system capabilities according to prep optimize and resource use. Is this low resource CPU use due to lower precision while keeping queue intact? Okay, well, okay, I might understand what you mean. So basically, you might be able to figure out, I don't know if you could like calculate what is a good physics FPS depending on everything in the game, essentially. Is that what you mean? I mean, maybe you can like define a bunch of parameters in the physics system to kind of help it determine. Maybe you could calculate what is a good like physics FPS. I mean, for this game, it doesn't matter because it's gonna be such a low effort CPU wise, you know, game. It's not real time. The only thing that's gonna like be heavy for, I guess, the heaviest thing is probably gonna be the animations and everything like that. But yeah, that's gonna be yeah, this game doesn't require much at all in the case of that. So I mean, it doesn't matter if the physics FPS is 60 or 10. It can be 10, I guess, but I'm not gonna mess with that until if we ever will reach some issues with with performance. I might try to mess with something there. Comp time only best and guesstimate risk. Yeah, well, the problem with that is you would have to somehow, I guess, run the actual game, you would probably better to just run some simulations of the game and actually render stuff to get a good idea. I think. But okay. Cool. What do we want to do this time? I'm not sure if we have like a to-do list or anything like that. It's just part of this, yeah. So that this is just old stuff. I'm thinking like I'm wondering about like the gameplay about this game. Is like, because I feel like we're kind of like in a fork in a road here. Because I'm feeling like it could potentially become more like a puzzle game than like an actual like RPG. But then again, I really enjoy RPGs. And I've never really... Well, I do enjoy puzzle games as well. But I just... When I imagine this game, like future features of this, like the vision of the game, I imagine more combat and cool things happening. Maybe you have like a party, like AI people helping you out to kill your enemies. Maybe you spawn a, you know, an elemental or some kind of helper to help you, like a golem or some other stuff helping you like win fights and stuff like that. So essentially just a kind of like a roguelike, essentially with like animation, like animated movement and like very simple graphics like this. And if we go down that route, it can basically be however complex you want, but it can also be very simple as well. Like right now, we already kind of have, you know, a super simple you know, mechanic. Like it's already sort of done in a way, in some sense. But then it's just a matter of like adding more and more things. So, but then there's a question. Then the question is, okay, what if we want to have like ranged weapons? What if we want to have like spells? How do we actually control that? Because if this is going to be a mobile game, for example, and like, well, first of all, if it's a mobile game, how do you actually move around at all? Like, do you do a swiping motion? That's the first thing that I thought of, like a swiping motion. So you swipe to the right to go to the right. You swipe to the left to go to the left, and so on. Or do you simply press where you want to go, and that's your target? So you would, could be able to simulate that by pressing there, and you would try to go there. Perhaps something like that. One thought leads to a gazillion others. Yes, that's usually how it goes. So genre-wise, basically a Gauntlet and Bard's Tale, but modern. Well, I don't know if you've played Rogue, which is like the original, you know, Rogue, where the term roguelike and roguelite comes from. I can show you here. Let's see. Rogue game. This is the original Rogue game here. Oh, it's actually on It's actually on Steam. What? Yeah, it came out in 85. 1st of June, okay. How much does this cost? 3? Okay. But yeah. This is Rogue. Essentially, it's it's kind of text-based. I love this trailer format they have for this. So basically, yeah, you go through these, cave systems or dungeons. And yeah, they're kind of like, I think they're randomly generated, procedurally generated. And it's like everything is text-based, but that's like just how it worked back then. And then you have all these different kind of objects. You have like monsters, enemies. You have like level stats and gold and stuff like that. I've never actually played the original, but this is the game that spawned a lot of stuff. And after this game came out, you have things like, what the hell was that called? That was very popular. Netscape. Wait, no. Rogue game net. It's kind of a weird name because it sounds like some kind of browser or something. Is it Netscape? No, Netscape Navigator. That's not it. It's like net something. What the hell is it called? NetHack. Yeah, because it doesn't sound like a game. It sounds more like a place where people share hacks or something. But it's actually a roguelike. What the hell is this? Is this the actual... Wait, is this the... This is the website. Okay. Well, this was like a really... Yeah, 2026 version 5. What the hell? They're still updating it. Yeah, but anyway, NetHack. Here it is. This is NetHack. So it kind of expanded on the ideas of Rogue and did a whole bunch of stuff. There's a lot of these games you can imagine, because it's like, it's such, it was terminal based, procedurally generated. There's another really nice one is ADOM. Now this came out in this is like a new version, but then you have like the old version. This is like the new version that came out for Steam, but then there's the old version. Where's the old version? The old version is just ASCII as well. And ADOM, I played this a lot. It's actually really fun. ADOM is like a super classic. You should try this one, because this one is incredible. It's so much content in it as well. Why do I get like Russian here? Okay, but anyway, so that is kind of like the original Rogue game and its kind of spawn-offs. And then you have games like, for example, Binding of Isaac. It's a Rogue light. Like, you have Rogue likes, which is kind of like these games, where it's like it just looks like Rogue. It's basically Rogue but expanded. And then you have Rogue lights, which kind of kept a lot of the mechanics, like some of the aspects of Rogue, but applies it to kind of more modern takes. Where Binding of Isaac essentially, well, they kind of invented a new genre, to be honest, because in Rogue, you have one character that you go around and you try to win the game, essentially. And it's easy to die, so you die. And every game, some of the things, like I think ADOM has it where every run, like every time you start the game, all the potions are kind of randomized. So you find like a yellow potion or a blue potion or a red potion, whatever, but you don't know what they do. even if you played the game before, because every time you start a new character, it's gonna be randomly determined what potion does what. And once you've drank the potion, now you kind of know what it does because you tested it out. So that kind of thing ended up in Binding of Isaac, where they have the pills that you don't know what they do, so you have to try them before you know what they do. So that is one aspect of it. Another aspect is just procedural generation. Doing a run until you die. A permadeath is another aspect that it has. I'm not sure if I'm gonna have that in my game though. Permadeath, I don't know. It depends on what kind of game we want to make, but I don't know about permadeath. The thing about permadeath is like if we have permadeath, then we can kind of design the game around that. But if we don't have permadeath, I feel like the content could potentially be like it potentially has to be longer or something for it to feel like. I think another really good aspect of roguelikes is replayability. So every run is gonna feel different because there's so much variation in the game. There's so many different things, like everything is procedurally generated. You get like new levels, even though, you know, sometimes you can feel like they're the same because it depends on the generation workings there. But there's like, you know, procedurally generated levels, random items. Maybe you can pick another starting character that gives you like different stats or different abilities to start off with. You know, you have random events happening, random rooms with different things in it. So everything feels, so every run is like different because everything is random essentially. That is a huge part of roguelites, is like everything is random. So, well, not everything, I guess, but it's like a lot of things are like random to increase replayability, because the whole thing is like you're gonna start a game, it's gonna be really hard, and you have to get a good run to get far, and then you get like further and further, you get better and better at the game, you get further and further, maybe you win the game, but you can still replay it because now, let's say you want to try another class, you want to try like a mage instead of a warrior or something like that. So it has a lot of replayability because of that. And it's the same with Binding of Isaac, because there you unlock more characters to play with that starts with different things. Everything is random, like all the rooms are random, the dungeons are random, the items are random, and you unlock, and also a new thing that came with, I'm not sure if Binding of Isaac was the first game that did this, but it also unlocks more items as you progress in the game, and it unlocks, like, you have a kind of a permanent progress through the game, so you're kind of unlocking more of the game as you play. So if you complete the game in your first run, that's not the entire game, so you have to like complete it multiple times in order to like get like through to the last levels. So, and new items are gonna spawn in the dungeons, like after you completed certain achievements or progressed through the thing. So I'm not sure if Binding of Isaac was first with that, but that's also a huge part of roguelikes nowadays. Like, that's a huge part of many games actually nowadays, is where you unlock a bunch of stuff along the way. That's a really huge part. Watch a friend playing Binding of Isaac, would not play because too chaotic, flashy, but it still left an impression. Yeah, it's not for everyone, I guess. It's but it was extremely popular. Funnily enough, I love procedural generation, on the spot, made up new compositions of everything, but I hate not being able to revisit the exact seed. I mean, I guess, you know, potentially you could just have the seed, because it's like it's not actually non-deterministic. It is deterministic, you could potentially, I mean, in all of these games, since, it's not truly random, it all depends on a seed. So potentially you could provide a seed to actually get the same thing happening. Although, I mean, okay, maybe some games might. I mean, I'm saying potentially. It depends on how they implemented it. If they want it to be random, they could use like based on time or something like that. I think in my game, maybe we will provide a way to kind of say like, yeah, you can determine the seed. Let's have you be able to determine the seed. So what's also nice about this is that I finally get to try out some like procedural generation with dungeons and stuff like that. Like I always wanted to kind of make these kind of room algorithms, like making rooms and stuff like that. That's so cool to me. So I always wanted to make a roguelike, and this could be the entry into that. So maybe I'll just make a roguelike, except I guess the difference would be kind of graphics and animations and stuff. And maybe simple controls. I don't know. Maybe I'll just make a roguelike, actually. I mean, there are a lot of roguelikes like on with graphics as well. But yeah, it would just be fun to make your own. Okay, so, but I was just thinking of puzzle games, just because of how this works here, where, you have 2 moves before the goblins can do anything, so you can kind of like puzzle your way to optimally defeat them somehow. Like this. And then you could create these puzzles where you try to, like, you have limited maybe health or something. See, now I take 2 damage. And you have to kind of defeat, like, that is also a possibility. Like, you have to defeat all the goblins without taking too much damage. And you have to kind of figure out, okay, how can I defeat them more optimally? But I don't know. I feel like making a roguelike is more fun. I guess realizing differences between seed controls, everything seed controls, only starting condition, but everything is random, for example. Well, everything is random. So basically, the thing is, yeah, some guys can do that as well. Like you have the initial seed determines some things, and then you have a randomization based on other non-deterministic things. Pseudo non-deterministic things like the current time or something like that. To even if you provide the same seed, you will get some variation anyway. Or you could make it fully deterministic, where you provide a seed and everything is exactly the same. However, it could also be determined by player movement, for example. Like if you make I think metagames do this as well. Like depending on how the player moves, you get a different seed, like you get a different like outcome as well. So it like feeds into the behavior of the player as well. You could have something like that. So then you could still play the same world. So initially everything would be the same, but then as you progress, maybe things change because now you chose to do something else. Or you can make it so that all locations are the same, like all the layouts of the dungeons are the same, but the monsters are different, or how they behave are different, or something like that. So it's like, I don't know. Maybe we'll start out with having everything be exactly the same, except for, you know, actual reactions to the player when you actually like try to attack them and stuff like that. But all the kind of procedural generation is the same. Could probably start out with that. Okay, I want to make kind of like so I want to actually make this town. So also when you go into a town, like I don't even know how this would work. Like, do we actually want an overmap? Or the overworld, I mean? There's probably not going to be any enemies on the overworld or any creatures at all. It's just going to be a way for you to move around. Maybe you can get into like random battles. Maybe that will be something like a Final Fantasy, except you get like launched into, like, you zoom in to like a randomly generated spot. Like, let's say you're in a forest when you walked on the overworld, I mean, overmap. You zoom into a forest type area with a bunch of random enemies like ambushing you or something, or like it's an event. Maybe you even have a choice before you like, maybe it could be different events. Like, you're moving across the map, you get like a message that's like, you're being ambushed and you didn't have time to react, so you're just getting ambushed, and they kind of spawn like close to you or something. Maybe even get a swing on you before you can even do anything. Maybe there's or if you're lucky, you say like, you see a bunch of goblins up ahead. Do you want to fight, or do you want to evade, or something like that, or sneak around, or something like that? So that would be kind of cool. Wait a sec, does the game run through a CRT filter? It's so curved. Yes, it's a CRT shader filter. Hello, Blue. What's up? What's up? Welcome back. That would be cool. I'm thinking, I like this Overlord. Why do I have so many names for it? Overworld idea, actually. Let's not create a bunch of stuff here. And now it's kind of, you know, you can go, this is the overworld, you go around, you get into a fight, you will like move out of that, and you want to get to like a town. Now we're in a town, so now there could be other entities like in a inner like location and stuff like that. So that could be cool. But yeah, let's see if we can make this town here. We can go to, I'm already thinking about Contime stuff here, but we'll see what happens here. Location, town. Because what I was thinking is we could just make, so this would be the, I could just make the layout be as a multi-line string, and just like this we have, I don't know, how much is this, 60, so let's do 12 times 12 times, what is it, 12 times yeah, a multiple 12. Let's do 12 times 5, that's gonna be 60, right? So 60. So here we have 60 in this direction, and then we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 tiles high. Wait, doesn't need to be a multiple of anything, really. 12. So, for example, what I'm thinking is you could define, let's say you define a layout like this. What about the town settlements, etc.? Are they restricted to a physical cell? Do they have a reach, aka the planes around might be part of it? Yeah, that's a good question. I think it's just gonna be in magical pockets. It's like you're not gonna be able to move, like zoom in. It's not like Dwarf Fortress. I don't know if you know that game, but that game has like full simulation of like the whole world. And you can, well, not full simulation, but it doesn't have like on detail level. It has like different detail levels. So it has, but you can zoom in on any part of the world and essentially move in the zoomed in version on over the whole world, and you would be able to move to towns and castles and all that stuff. That's how it is in Dwarf Fortress. I'm not going to have that in this game. This game is simply going to be you have the overworld. That is one like dimension, let's say. And then you go into the town. That's just going to be its own map. It's not going to be, you're not going to be able to move out of the map like in a zoomed in mode. You exit the town. That's going to automatically zoom you out to overworld again. And then if you get into a battle or an encounter, you zoom in, but that doesn't mean you can like move around infinitely. You have this little map that you move around, and you go to the edge of that map and you exit, and now you're on the overworld again where you were before. So it's just going to be like that. It's like, I mean, you might potentially be able to zoom in on every square of the overworld, but it's just going to be, depending on the type of the tile, it's just going to be like, that's the kind of map that's going to get generated based on where you are. So that's how it's going to be. And I guess it has to be consistent. So if you zoom in on the same square twice, it has to be it has to look the same, I guess, maybe. I don't know. And that potentially you could just actually zoom in yourself to try to look for stuff, I guess, maybe. Look for hidden things. Actually, oh my god, that's actually pretty cool. Wait a minute. What if there's like a hidden secret and you get like clues to a location that you have to kind of figure out? So when you're walking around in the overworld, you have to find a specific spot. It kind of like Zelda 2, where they kind of have that in Zelda 2. Yeah, actually, this reminds me a lot about Zelda 2. Actually, you can think about if you have played Zelda 2, the kind of overworld and the relationship between the overworld and the zoomed in parts are exactly going to be the same, essentially. It's actually exactly like Zelda 2. But what I was thinking is, except for if you are allowed to kind of zoom in anywhere, you get to this restricted little map section, but maybe there's a hidden secret in one of the tiles on the overworld, and you have to find it by, well, you could either just search every tile, I guess, but if you, let's say it's going to be really hidden, so it's going to take a really long time, I guess. But it's going to be, but it could also be, because it's procedural, it could be random where it is, so you might get a clue to where one of these things is. Like, I hear there's a hidden treasure in between the red mountain and the blue lake or something like that, and then you have to go there and like find it. Maybe there's like a treasure hunter class that like gets more like better hints or something like that, like randomly finds treasure out in the wild or something. It could be, I mean, oh my god, the possibilities are endless, man. I'm actually excited about this project here. It's actually pretty cool. My specific thought was regarding the town contracted NPC, so to say, if anything. When they fight you, will they get initiative aggro, and when they are near the town, so to say, even in Pocket Universe? Let's see. Yeah, quests, of course, of course. It's an RPG, there has to be quests. You should play Adom, because that has quests as well. And it's kind of like this. It has an overworld. I don't remember if you can get into fights on the overworld. Maybe you can. I don't actually remember. But you can visit different parts. You can visit a bunch of locations. And like some locations are more difficult than others. You need to level up to be able to visit other locations. So essentially you go to the town, you get a bunch of quests, you go into some dungeon, you clear the dungeon, you go back, you complete the quest, and you go on like that. It's actually pretty cool. And the overworld is the same. All locations are the same, except the contents of the dungeons themselves are gonna be randomly generated every time, and the layouts of the dungeons, but they will have kind of the same kind of theme. So there's like a pyramid, there's theme, or like a cave theme or stuff like that. But yeah, the more I think about this, the more excited I get, because there's like endless possibilities. I just have to find kind of like a path to where I can kind of settle on a nice like game mechanic, like how you actually do things, like basic things, and then like combat, stuff like that. I mean, if I'm just gonna make it a roguelike, maybe I'll just forget about this whole mobile thing. I'll just make it a full-on roguelike with keyboard controls, essentially. Because most roguelikes have super complicated keyboard controls with like the whole keyboard is mapped to something. Every key is mapped to something. There's a button in Adom to clean your ears, for example. So which might be handy sometimes. Man, I just love roguelikes. Roguelikes are so cool. I haven't played Adon in forever. It's such easy to get into as well. Like you just start, it's quick. There's no animations either. I mean, it kind of speaks against my game, but there's no animation, so you. I feel like I'm out of frame for most part. You will have to, yeah, you just move. You can move pretty quickly around. Like if you've done it 100, it's actually pretty good, because if you've done things like 1,000 times before, maybe you don't really want to watch a bunch of animations. Maybe actually there's a way to turn it off. Turn off animations. Then we don't even need to show. I think in Adom they have kind of the same idea that I have. Well, I guess I basically took it from there. Is where everything happens like kind of immediately, except when you or someone else fires like a magic missile or something, like a projectile or like a ranged weapon. You actually see the projectile go and hit something. And if it's like let's say it's there's like things like bouncing spells. So there would be like a beam going out and it bounces against the walls. That is fully animated. And then you have to wait for that animation to end. But movement is instant, like you instantly move to the next square. So maybe we'll allow to like disable move animations if that's not, if you don't want to see that. But it could be pretty important to see that you got a fireball to the face, for example, instead of just seeing like, okay, now you're burned to the crisp and everything else around you are now everything is on fire. You probably want to know that actually happened. So I mean, you want to know everything that does happen, but it's like movement is such a simple thing that, yeah, either we could, maybe you could determine like the speed of the animations. Maybe you could determine that they're off entirely, like movement animations, for example. But then we'll show like, yeah, you know, spells and stuff like that. Please allow disabling all kinds of animation. Yeah. Well, maybe not. Maybe not like spells. I think spells should probably be allowed. It kind of depends on the impact they will have. If spells have like major super impact on what's happening, then you probably do want to see them at all times. Yeah. But anyway, let's see if we can make this house here. So I'll just make like a house. I'll just make this example house here. So this would be a door, I guess. It kind of looks like a roguelike here. And then the interior floor, I guess, could be commas, maybe. Or I don't know. And then we could have things like a bed or something, like a bed and like a maybe like a cabinet. Maybe here over is like a table with chairs. So uppercase C is like a cabinet, B is bed, C is like lowercase c is chairs, uppercase T is table, and then yeah, and then you can have like another house or something. I don't know. Yeah. And maybe, I'm not sure if we need different like tiles for this, but we can start here. Actually, you know what? Let's go into here and see. So what we want to kind of map things here. So let's go over to where we could potentially have these things. Over here, for example, we have a bunch of like, we have wood, we have stone, bricks, all kinds of stuff. We have doors, a bunch of different types of doors. Cool. We have some block type stuff. Stairs, important, very important. Dark stones, maybe this is stone floor. Yeah, these dark things are like floor boards. What I do not like is that in most modern games you either have enforced animations, none at all. For spells, which may apply to NPC spells, it's important to show us other outcomes so we can pre-plan ahead. Yeah, exactly. Roads here, we have a bunch of stuff. So I think, and here's like interior, like tables and chairs and stuff like that, and beds. Yeah. So, and fences as well. Yeah. Stairs or ladders. Yeah. Cool. I guess we'll start with like, let's just do like a brick house, I guess. Sure. And we can have windows as well. Yeah. Now what's the difference here? This feels like a corner. And this one is more like, is this tiled? What about the other? Like, do we just flip this and we get the other version? I guess. Because this feels like a corner and this is the middle part. So we need like a corner of the bricks, middle part. And then we also need, I guess, the roof tile, like, what's gonna be like, maybe this could be, no. Okay, let's look at their example, because they have like an example of a house that you can look at. Yeah, here for example, well, it's just like, it's just this. It just looks like this. a bunch of wood, and then, yeah, I guess that works. And then this is the floor. This is kind of what I was thinking about. So it's kind of cool. Also, potentially, maybe you could build your, maybe you can have a map. Actually, maybe you could build everywhere. I didn't think about this, like destructible terrain, and oh my god, there's so many things. Okay, but anyway, let's have this be like wood walls. This is the floor, this is a door. Do we have like windows and stuff? There's probably there are windows as well. So let's have like a window, like a couple of windows, I guess. Maybe like a window here, actually. I don't know. Okay. Cool. And then, yeah. So what I want to do is I want to map these characters to actual, like, the tiles. So let's go to map. Because here we have like a bunch of different tiles. The thing is, when we generate, let's say we generate the town, everything is planes. The thing about the tile here is that it's just a tile type. We would have to add the types here, I guess. I mean, I guess that's fine. Okay. Okay, well, first I want to go back to the town. I want to create the maps of what we need. So we would need like map char to tile type is a function that takes a character and maps it into a tile type. So let's return switch on char. Right. So if it's dot, then it's planes, for example. I'm gonna say unreachable otherwise, or compiler. Char not mapped to a tile type. All right, so we have dot is planes. That is like floor. This is wall. Bed, this is bed. C is cabinet. Small c is chair. T is table. And W is window. And then we need like different kinds and stuff like that. But let's start with that. So we need these things. So let's go to map and let's add these things somewhere. Where are the tile types? Where's the tile types? Here. All right. And now we have a whole bunch of stuff we need to add. Was brick wall cry for an exercise in procedural programming? Maybe you could build anywhere. Fortnite 2D in the making, yeah. I don't know about building. Well, we'll see. It's such a huge component. It would be cool though. Floor is not solid, wall is solid, bed is, I guess it's not solid. Cabinet, I guess it's solid. Wait, is bed solid or not? I guess it could be solid. Chair is not solid. You should be able to move to a chair. A table is solid. A window is solid. Solid. All right, so let's move these things. You know what? Let's do this. Let's do like inline else t if t. Yeah, let's just do this. If is solid t, we're gonna have infinite, otherwise we have 1. There we go. Oh man. All right. What else are we dealing with? Right, so here's we determine the actual graphics of everything. So let's grab all of this. And I'm just gonna do that. All right, so we can start out with that pattern. Okay, so floor. Where is the floor? The floor is one of these things, I think. We picked the dark ones for like floor stuff. If you look at this, they have like the things on the ground are lower like brightness essentially, just otherwise it would be too busy. Like even this is kind of busy with all the bright green vegetation, maybe. I don't know. Or yeah. No, yeah, that makes sense. Like floors, things on the ground are dark colored. Makes sense. So this floor would be one of these things. It's kind of fancy. I mean, I guess it depends on what we're going for. Let's just pick this thing here, I guess. Whoops. This is 105.79. 105.79. And then we have the wall. We're just gonna pick, I think, either brick or the wood. Let's pick the brick. See how that feels. 105.40. Bed. There was actually like multiple types of beds, I think. Well, actually 2. Okay. And here's even like a table with chairs on the other side. Or is it a bench? I guess it could be either be whatever you want it to be. A bed. Sure. Let's do that. 1,469. 1,469. Cabinet. Actually, do we have a cabinet? We have like this thing. I was thinking more like or maybe, yeah, a full on, you know, this thing here. Yeah. This is a cabinet. 174.69. And we have a chair. We have a bunch of chairs. I like these chairs here. Let's do this. Kind of like a iconic chair. 209.469. And a table. So we could pick this thing. We could pick this thing, like a round table. Yeah, let's go with this one. 79.469. And we have a window is something over somewhere. I think it's up here maybe. Yeah, here's the window. We'll do like these ones maybe. Wait, if it's gonna be a brick window, it's probably gonna be these ones. Yeah. So let's do this one, I guess. 16940. Could also make like brick window 1, 2, 3, 4, you know, so that you can kind of choose that depending on maybe. Okay, there we go. So now we have all that. Okay, now we just need to write the code to turn this into, you know, a map essentially. So what we could do is we could go to map. We can say, for example, map. There's like generate map, generate world map, generate town, generate blah 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 blah. But I also want to have from layout, which gives us a string. And we also need a function that takes a character and returns a tile type. This is the map function. And this gives us a map. And there we go. So let's get map function. Map is this. So, well, let's just copy that. Oh yeah, we need an allocator. We don't need game because we don't need like noise. Okay. How about declaring the offset as factors multiples? You can easily switch to another image map. Ah. Yeah, like switching out, like defining like a set of like walls and windows, and then using like different, depending on like, yeah. The trouble I'm having is like, what if you want? The trouble is like maybe composing layout. Like this could be like, you know what? Maybe you can store like references. Now let's say this is like, let's say we have like here, we have like, well, this is like house 1. This is house 1 over here, and then we place like house 2 over here. And then you have like, well, this is like house 1 layout is this thing here. And that basically, when you encounter an at h1, we will kind of place at the center of it, we will place like the house layout in there. So it's going to be like a reference. So it's going to fetch out that thing, put it there. So in that sense, you can kind of design the level like that. That would be kind of interesting. But yeah, because then you can create a function that's like, okay, well, these are kind of generic, you know, walls. You can switch out the palette, the tile palette, to have like a different kind. Yeah, that would be kind of that would be pretty cool. Okay. And then you can also potentially, if you get a layout, you could potentially also like say, well, H1 will map to house layout with this tile palette, and H2 will map to this thing with the house palette and stuff like that. Oh, it's done. Okay. But yeah, let's do this. Let's do the layout first. There's so much things you can do. There's so much fun things to do. So much fun things to do, so little time. Okay. So we have the layout. Actually, we need the dimensions as well, because the layout is just a string. We need dimensions. Actually, no, we can... No. We can calculate the dimensions. Yeah. So we get like width and height. It's gonna be calculate layout dimensions from layout. So let's have this function here, calculate layout dimensions. And this will give us a board vector. And so what we'll do is we'll create an iterator that's gonna split layout by new lines. We are going to loop through all those, and essentially we're gonna have the width be a, what are you actually, I32? Yes, I32, and then height I32, and then we'll return width and height. Whoops. And then line, then width, essentially just going to be line of length, because every line needs to be the same height, or I mean width. I guess technically we don't need to have that. Technically we could just pick the one that is largest. So we could take the max from width to line length. So we're kind of covering our like cases there, so we don't, yeah, so we just take the one that's largest, yeah. And then height plus equals to 1, and then in the end we would have, so let's say there's like 2 lines. I think the iterator would go through each line. There might be an extra line at the end. So maybe if we're at the end, so I'm gonna say like current line or last line is a string, which is undefined. Actually, it'll start being empty, and last line equals to line. Whenever we get out, if the last line, if the length of the last line is 0, then I think we reduce height by 1, because then we don't, like, the last line doesn't count if it's empty, right? I guess that's true for all the last lines, but this will be particularly interesting for the actual last line, because we might get like 1 extra height with an empty row for all maps that we don't want. All right, so that will calculate the layout dimensions. And now we have the tiles there. Generation type, we don't have generation type. Actually, do we have generation type? Do we care about generation? Why are we storing this? We don't actually care about this, I don't think. I'm not sure why we're storing this. Like, we're setting it, but we're not actually using it anywhere else. Yeah, I don't think we need to store this. It's not really interesting to store this. I'll just remove that. Doesn't matter. Okay. Okay, so from layout. All right. Now we need to go through also now like all of the. So we need to go through like width. Do I need to? I think I need to incast this. So that's X. We need to go through height. That will be Y. Is likely defined by visible characters. Yes. Think of E of F can be, which can be treated as separate last line depending on implementation. Yeah, so these string, I mean, these strings are come from, it's these strings here. It's not, I'm not gonna load in a string from a file or something like that. I'm just gonna define the layout right here in the source code. So I'll just have the string here, put it in. So at the end here, there's no EOF or anything. It's just the end of the string because we get a, like the strings in Zig have a length built in. So it's like they have like their length in the actual, like this variable here is like a combination. It's like it's like a struct with a pointer and a length. So Zig knows, like we know how long this is. So we know when we reach the end. The question I had was, will there be like an extra empty line at the end here? I wasn't sure of that. So I just also, if you do like this, you will get like an extra line within like that is empty, I guess. All of these lines, like the case that I was kind of guarding for is like if you do something like this, maybe you want the rest to be empty or something like that, or you don't have to spell out all the dots or something. So we have like a default, maybe we'll have like a default, or it's gonna be empty or something, I don't know. But let's, yeah. Open nice from water triangle, actual text file building your own. Yeah, that's true, but I'm not gonna think about that right now. That's gonna be something extra later in that case. I mean, it could be for my own sake, compiling maps, like, or reading in maps and making, we could still use this function here to actually do that as well. Although most things are probably going to be procedurally generated though. But we could maybe do some, like, I don't know if, you know, Minecraft has some interesting, like Minecraft has, like, you know, the whole world is procedurally generated, right? However, then they have things like structures, and structures are not, well, I guess they are like, they have like random elements, but it's like they are always the same kind of layout essentially, or they have always the same like structure. But then there could be some randomness like within, but those structures I believe are essentially like a table that's just pasted in, I believe. So so you could have something like that. You could define like structures that you kind of ship in, but I guess it would be less interesting maybe here, I don't know, because of the 2D-ness of it. Maybe, I don't know, it depends on how detailed or whatever you could do with it. Maybe you can ship it with a script that has like extra mechanics. That would be kind of cool. Like I could allow for like Lua here. Yeah, but anyway, maybe I'll ship the Zig compiler so that you would have to compile the game before you run it. Like running the game actually compiles the game. I don't know. Anyway, so like download the game. You actually download the source code and you have to compile it with Zig, which should be super simple. I don't know how Andrew would feel about that though. Anyway. Okay, so here we have this thing happening. Actually, you know what? This is kind of, well, you know what? No. Yeah. Let's do an index. Okay, I've been here before, so I know I know the pitfall that we're going to reach here. I know there is a pitfall here because yeah, I'm gonna explain it here in a second. But what we want to do is we want to loop through all the characters in the layout, right? Right. And then what we want to do is we could actually just do a split iterator. Actually, maybe now that I think about it. No, let's just do like we have index I. This is gonna record which index of the layout are we talking about. Now, I think we're gonna need to flip these because we want to go through I or X first, and then this will be increased by 1 in the end. But the current character is going to be layout I, right? And then we have to advance the index pointer to go forwards. The issue becomes that layout has a bunch of new lines in it that we don't actually want in our tile set, so we have to kind of discount those. So when we are changing Y, or actually when we're at the end of C, maybe we can even check, like we could just check. No, because we're going through, right, we're just going through X here actually. So we won't we will never get to the new line. Also, what if the new line comes before? I think we have to have a state there. Reached new line. Whoops, I don't know what happened there. Reached new line. So if we reach the new line, then we'll just, I guess we'll just continue. We'll increase and continue. Okay. Otherwise, we grab out the layout, we increase this by 1, we check if C, we check like reach new line is equal to C is equal to new line. So if we reach the new line, then we set that. And if we haven't reached the new line, now we want to say tiles I. No, it's not going to be I. Actually, we have like, we kind of have 2 different I's, but this is going to be like X plus Y times width. That's going to be. Except this is a U size. Will this work? I'm not sure. I don't think so. Let's do like U size incast. Okay. Because these are U size, this is an I32, and yeah. Okay, so tiles are, you know what? I'm actually bothered by this. Let's just do vector 2. U size instead, and then intcast. So we just do intcast once. I'm so bothered by that. Yeah. All right. Also, max 0 height, so it's not gonna go below 0. Okay. Because now we don't need to cast it now because it's a U size now. So, and we don't need to cast here. Everything is fine and dandy. Great. However, we do need to cast here. What the hell? Or do we? No, we don't, because this is U size. Okay. That actually worked out better than I thought. Okay, so you haven't reached a new line. That means we have a tile type that we need to set. We have X, Y, and width. What is this thing? It's going to be init. Or it's going to be... What the hell? How do we do this? Well, okay, we just set it manually here. Okay. And it's going to be like tile type equals... null. Or does this work? Yes, it does work. So then we have the map function of the character, and there we go. So now we're calling. So now this should be good. We're looping through all the things. Every time we loop through X, we increase I by 1. If we reach the new line, we still increase it by 1. But when we go over to... But we won't reach the new line if the new line is at the width. So we also need, I think, to increase I by 1 over here. Because otherwise it's gonna be super weird. If we haven't reached it. So, and otherwise, the thing is here. we want to still fill in. No, wait. Hang on. If we reach the new line, we want to do this, but we still want to fill in the tiles. So I guess this would just be planes. This is like the default tile. I guess that could be, we could specify the default tile as an options in here. I guess we could have like options. This is like from layout options. From layout options, and then we can have default tile in case you have an empty one that's not specified. And this is a tile type, and it's planes. And then over here we would set you to be options default tile. Okay. So what about this? What if this is else? We always want to fill in, so this will be default as well. We don't want like an empty spot. That's not gonna be good. Okay, so this should turn the layout into a map. So now all we need to do is kind of go to town, and yeah. No, wait. Locations. Town. Where's like generate? Oh, location def. Get location def. This one's called from here. We initialize the location. Do you generate? Yes, you generate the map. So, right. This is the thing. We only have support for generation maps here, so we have to add another way of I mean, I guess we just have the map, really. Or like from layout. It could be also from layout or something like that. So let's do like from layout. We don't have generation size, we have a layout. And then we don't actually need width and height, because that is like, we can get that from the thing. We don't need seed. We could, yeah, we want settings, I guess. Now the map is going to be from layout. And then we need the map function. It's going to be a function from U8 to a tile type. And we pass that in here. We also need allocator. And options as well. Layout options. And really these things probably could be in an option, I don't know. Okay, there we go. From layout, so now we have that as well. And this one, the initialize the map. Yeah, we still kind of allocate the same thing like the tiles there, so that shouldn't be an issue. Okay. Great. Now let's go to locations. The thing here though is that we always, yeah, so what we could do here is like, yeah, this gets location def. This is how we kind of define the map or define the location here. So but we only have support for like one type of location def, which includes like generation type and all that stuff. So what I'm going to do is I'm going to change this into a, this is actually location def. This is like generate. Okay. And then we have a location def, which is a union enum. And then this is just one part. This is going to be generate. That is one possibility here. The other possibility would be from layout. Which only needs layout. It needs, well, it does need this as well. We need a map function again. Map tile type. We need options, which is map layout options. And there we go. I think that's it. So layout. And now here, well, what we also could do is we could say, we could move out these init functions actually and call you generate. And actually I want to rename this to generate and this to from, well, whatever. And then this would be generate. We would get this, yes. Return.generate. Yeah, and there we go. And then we have this one, which we will move out here. And you are going to be from layout. All right. So now this one is like generate, and this one will be from layout now. Okay. Oh, excuse me. And we need the layout of the town. And we need the map function. And we can also do like layout options. Okay. Unable to evaluate comp time expression right. Isn't this just a U8? Oh, it's not comp time, right? I mean, it kind of is comp time, though. You know what? Let's just panic. I don't know. Let's just unreachable here. No field, generation type in location depth. Right. So now when we actually create this thing, we have to switch on definition, and if it's a generate, then we get generate out, and we do that. Otherwise it's a from layout. And then we do location from layout. Name. And there we go, I think. Yeah. All right, def is generate. Okay, so now we can either generate a map or we can use a layout. Cool. All right, what's going on here? Line length, are you a U size? You are an I32. Why are they I32s actually? I think I just set them to be I32s just because of the return type. Since you're back at character-based maps, I thought about content use. If you do it as a pure render and from start to file-based ingestion, procedural generation files module. If you do it as a pure render and from the start use file-based ingestion, procedural generation to file as module. It's actual game that will never live in the game in that environment. I'm not sure if I understand what you mean. Like if we read in, if you have the source code in comtime, I guess it depends on if it needs the data in runtime. It would store it in the read-only data of the executable. However, if it doesn't need it, it could potentially like doesn't need to store it there. If we like transform it in comtime and then use only the transformed data, then that is stored in read-only data. Now, if we but if we want to do it the other way, where you could like dynamically change files and then rerun the game to have like updated data, that is fully, you know, dynamic, and you would have to read in the files when from runtime. Yeah, of course. I'm not sure if that was what you were talking about, but expected type map found. So this could be an error. So let's just try and forward that. And let's do a try here, I guess. Load. Wait, does that work? I'm just gonna catch unreachable here. Or we could catch error, log error, unable to load location, something, and then the error. The location is the key and error is error. And if that happens, I guess the game is broken and we exit one. Actually, this is bad, because then we don't actually the first will still run, so I think this should be good. I think the first still run, right? Or do they? Will this Sig, does the first run after process exit? No defer runs. Okay. So no cleanup is done, but in short. So I guess like once the quit is true and return. Yeah, I was like, what the hell are you talking about? But that wasn't actually, that was an outdated error. Okay, we got some kind of error. Reached unreachable code. All right, locations town 37. It reached unreachable code. So let's log error. Whoops. Error. Invalid layout char. I think if I say C, it's gonna parse it as a char, and like it's not gonna output it as a number. It's gonna output it as an ASCII, I think. Because otherwise, if you just do this, it's just gonna output it as a number. So C makes it an ASCII. Invalid layout char. And then I guess we'll say unreachable. Or we could just panic, maybe. Panic. Panicking. It's gonna be the at and those, yeah. Invalid layout char at, yeah. How did the panic thing look? It's just panicking, right? Invalid layout char. All right, so, or this thing here. Let's try this one then. If you offer the generation separately standalone, you can link to it at comp time, at runtime, and standalone. Well, the problem with comp time is like as soon as you've shipped the game, you don't have access to like you can't do comp time anymore. It's only going to be runtime. Comp time only exists when you compile. So there's like, then you would have to like, they would have to compile the game. Invalid. Oh, the door. Actually, it should probably be like D for door instead, because it doesn't really have a... You know what? Actually, instead of having a door, it should probably just be an open space, because otherwise you can't really get in. Yeah. Okay. And there we go. That's our little house. Nice. The windows look weird. Why is there like a black border? But yeah, cool. We can kind of like, you know, have a little layout of the house here. And the reason why I wanted to have a house was to kind of now test more as well. The goblins pathing there. Do we want to be bricks or wooden walls? I think I'm gonna change it to walls actually. Where's the map to tile type or here? All right, so walls. So the comp time requires compile, but if your game is simply a renderer, I can also suggest a file, then you can use separate generation in the comp time to prefab the files and still use. Oh yeah, I see what you mean. Yes. That is true. Could also make an editor. But now we're going too far, I feel like. Okay, so I need to find another wall. Let's pick this one. That's one in the example. 2753. And then I want to pick another window. Okay, so it's going to be one of these. It could be one of... No. This... Isn't this the window right here? No. I picked another one. But why is it like off like this? I don't like it. It's like off by... Whatever. Let's just pick this one. 183.53. 183.53. I don't know why it like jumps like that. There's like a one frame where you see another location essentially. Okay. Yeah, nice. Next looks good. I'll put this up into do. Bugs. When entering a location, another part of the map is visible for one frame. And yeah. Should we try this like paste thing? Because we could have like a union enum here where it's like, why would I even want this? It's just to be able to, let's say you have multiple houses that has multiple things. I want this to be a little bit wider or taller or whatever. And let's put a house maybe over here. Maybe it's a little bit larger. It's the mayor's house or something. Okay. Maybe the mayor even has like a room. Let's do like 3. So in here is a bed and a cabinet. And this could be a door. And then maybe a door up here with something else over here. All right. That's another. We don't have doors though, so I need to add that. Door is a door solid? I guess it's solid. I guess it depends. It's an open door or is it a door? I guess it's a door. Okay. There's no member name door. Yes, it has. Where is the door? The door is like one of these. I guess, yeah, if it's a solid door, it should be closed. So it's like this one. Probably going to pick maybe this one for these doors. 5314. All right. Mayor's house, the door is always open. Yeah. I mean, yeah, the entrance is open. I made it like that just so you can actually go in there. You can't go in here because they are locked. Yeah. Cool. We can even expand it a little bit more. A few more rows there. make a little house up here. I feel like Bob Ross. Maybe this house is closed and you don't see anything. There's like it's just a bunch of walls, and maybe there's like a window up here, like 2 windows, and the mayor has like a tiny hut with no walls in here. Some person here only has a bed and oops. This could open here. We need floors. One thing that this system can't do is have like layers. Unless we define layers, like multiple versions of the map. Because I've been thinking about, because the beds and all the tiles, they're kind of designed to kind of be like, it has like black background. But I've been thinking of maybe we'll make it so that you can see what's behind. I don't know. Maybe not. Consider this in 2026 and up, having an editor is like a top-notch feature. Yeah, it's really cool. Although it has to kind of be polished and good, I feel like. Well, maybe. Well, it has to be presentable at least, I guess. Mayor's house is doorless, always open, nice, yeah. Proposal, D small, lowercase d for door in rooms open, D for closed, capital D for closed. Main door becomes P for portal. Yeah, that's a good idea. Because it really literally support because you nested pocket maps to entering house. Well, I don't use it here though. Like this whole area is 1 pocket dimension. These houses are not their own pockets. This whole thing is 1 pocket. That's how it works. And well, I was thinking about chest. Wait, this doesn't work. Kind of like a weird layout here. Whoops. Maybe this one has 2 doors for some reason. Actually, maybe this is like a workshop. It just has like a bunch of tables. All right. Let's do one house up here, maybe. This was actually, I mean, it's kind of fun. Okay. How do you enter the town and leave it if not through a portal? For example, when town is fenced. Yeah, so leaving and entering a town is going to different pocket dimensions. But not leaving, entering houses. On the main map, you have at least 4 directions to enter and leave. Yeah, but it's gonna be like in Final Fantasy, where when you enter a thing, you're not gonna like end, like, it doesn't depend on which way you enter. You always gonna end up at the same place. So here's the mayor's house. Maybe we'll add, actually, yeah, roads. This one doesn't have a floor. It could be like a rundown building as well. Oh, and here's our NPC. Cool. We could also have this, like, you have hidden, you know, a hidden room. You open the door and it's gonna reveal the thing behind it. That would be kind of cool. I mean, yeah, that's how the dodges will work, because it's gonna be like fog of war, or maybe not fog of war, but what is it called? Like the black. It's gonna be hidden anyway, so I guess it's called fog of war. Maybe. I think, I don't know if it was Warcraft that actually came up with the term, but everything's gonna be, you're just gonna be able to see what you see as a character. And then you're gonna like explore at the same time. I think in Adam you actually see the whole map. I think. Well, maybe not the whole map. Well, do they have scrolling in Adam? I don't remember. I mean, you could just download it and try. Adam. It's like, it should be available on the website, like on the actual Adam website. Is it this one? No, this looks new. This looks like the new stuff. Where's like just the original? Get the latest version. The latest public available release. When did it came out? It works on XP Vista 7, 8, 10. Oh my god, it doesn't work on 11. Actually, I could download it for Linux. Ubuntu 18? Oh man, I got like 20 at least. But yeah, it does work on Linux because it's terminal based. That's what's cool about it. It probably works better on Linux than on Windows. Actually, maybe. ASCII version, graphical. Oh, this is the graphical version. But I don't want the graphical version. I want the text, the terminal based version. When did this come out? Why is there no timestamp here? Where's the timestamps? Release 101, version 333. What's this? This guy, Thomas Biskup, he was like the creator of Adam, was working on like a really cool new roguelike. I don't know what happened to it. It was called Jade. Like, I don't know what happened to this. I think he was trying to use like Java with what was it called? Q4J or something like that. It was like an insane, like weird domain-driven design library, something or other. It was like nerding down in like some programming stuff. But then the actual game looked really cool. But I don't know what happened to this. Okay, so then they went for Ultimate Adam instead. And the financial loss, oh man. Yeah, run out of money. Oh man, that's sad. Well, you can still play the original. Okay, so when was Adam 3.3.3 released? 2019. Oh my god. Well, I guess it's as good as any. I was just thinking if. Okay, so newest Adam terminal or ASCII version. Okay, that is the newest. Okay. So let's get that one. I just want to show you here. So let's get... I want to get this one maybe. 64-bit, sure, why not? Okay, I'm making a games folder for the first time. I don't remember how to do this. I think Z stands for gzip. X, V, F. There's some weird combination like that. Okay. And then can you specify out as well? You can, but it ended up in Adam anyway. Okay, cool. Oh, it's actually just, so look at this. Wait, this file is like, okay, it's 4 megabytes. Oh my god. This is so cool. Roads, right? What would be cool would be paths, developing track in each cell, how much was traveled, and according to user modifier for a floor type. That would be cool. That was also what's cool, like what's good about these games is that they are so simple in a way that, well, they're both complex and simple. They're like the world has a simple structure, so you're able to do a lot of things to it. play the game. You have started this version of Ada for the first time. In case you're a total new player, you want to check out. Well, I don't need to check out a manual. I've never seen this message before. I don't think. Honor the license of the game. Yes, thank you, Thomas Biskup. Okay. Wait. Oh. Man, what is this? What is this ad here? What the hell? This wasn't in the game when I played it. Well, we have the full story. We have quests and content. Yes, he's German. Graphics, sound, music, UI. What? I don't want that. Well, music, sound, UI. What's this? ASCII display, text only, yes. Customize lethality threshold, like, so you can do a whole bunch of different things, and there's like weekly challenges, blah 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 blah. We don't need that stuff. We want to play the actual game. How do I go? How do I exit? Okay, now we're in the actual game here. Welcome to the entrance of ancient domains of mystery. You are but one step away from embarking on a wonderful, terrifying and exciting journey into the dark dungeons, mysterious caves, and dozens of other strange places. So you can start a tutorial, or you can generate a roguelike character. You can load a save. Wait, I thought it was permadeath. Wait, I think... Oh yeah, there's quick save. Or there's like save and quit. And then you have to load in again. If I load, there's nothing to load. I can view the high scores locally. I can quit the game, blah, blah, blah. Generate a roguelike character. So, you can let fate decide. Wait, is that just space? I guess. Okay. And you can get a random route. So, you choose a race, and I think you choose a class as well. So, let's just do, I guess, just a random. And then here's a class. Now, they are very different. I don't remember much about anything about different classes. I think I've never really tried every class. I've just tried like the most like iconic ones. But there are, oh yeah, man, it just comes flooding back to me. Oh man, okay. So here's some hints if you want to like have an easy go at this. A dwarven paladin for a strong close combat fighter. Cool. A high elven archer for a strong range fighter. A gnomish wizard or elementalist for a strong spell caster. So depending on which race and all that you choose, you get like different stats. So I guess, you know, I'll just do a random one. Okay, and here's my kind of backstory. You're born in the month of the Falcon. Aspects nobility, hunt, force of personality. I have no idea what that does. Game effects. Okay, it actually tells you. Very good at surviving in the wilderness. Oh man, I remember now. Oh my god. +2 initial willpower, +1 initial charisma, 1 free talent to be a male mist elf. I have no idea what that is. You have silver hair, white eyes, and a white complexion. Okay, mist elf. We're white, essentially. We're silver, white eyes, and what, like, you can't see us. If we're in the mist, we should probably be like invisible. You remember rising from the mists long ago. So we're born from the mists. Your brethren welcomed you into your physical existence and cared for you until you managed to copy your own. Thus decades passed. As a young child, you were taught by the elders of your race. They showed you to the whole breadth of creation and opened your mind to encompass whatever your life goal would become. Thus centuries passed. So you live for a long time as a mist elf. I guess all elves are like that. You spent your youth owning your skills and preparing for the ultimate quest that will change you forever, the trip to the mists of destiny. Thus millennia have passed and empires rose and fell. As a young adult, your community... Shouldn't we be OP by this point if we're like centuries old with all the skill that we have? As a young adult, your community prepared you for the final step towards adolescence. Your destiny quest in the mists of time. In the full knowledge that this quest would change you forever, you finally enter the mists that birthed you and emerged changed, as decreed by the dreamers from beyond. At the age of 8,143, you end your apprenticeship. That's some nasty requirements there. You are now a fully learned weaponsmith. Yay! Okay. Okay. So we have a bunch of choose a talent, right? So talents are like powerful upgrades. Look at this, like double starting money, for example. I mean, I guess double starting money. I mean, yeah, you get double, but how much do you have from the start? I don't actually know. And we can page down, we can move down, go up. So we have like potent aura, power points. I believe power points are like magic things. I'm not sure how much magic we're gonna do as a smith. Also, can we create weapons as a smith? I actually don't know. But there's so many different things here. You can get like +2 attributes. Perception, charisma, dexterity, mana, appearance. Hit points, learning, speed, strength, willpower, toughness. We have combat talents, aggressive. We get like extra damage or extra hit to melee. I'm not sure if that means accuracy or, yeah, I guess the accuracy because it says damage down here. 2-handed weapons, -50 energy cost. So it kind of reminds you of maybe like those pen and paper role-playing type games. But okay, let's just get something here. We are a weaponsmith, so I don't really know what to pick here. Maybe we're a melee warrior, perhaps? So maybe we'll choose to be affinity with something. We get a lot of hit plus damage from here. The problem with picking this is what if you find like an insane club and you picked affinity with swords? I don't know. Miscellaneous tread times healthy, long stride. Movement costs 950 energy points. Okay, let's just pick something here. I usually go for like good learner, or because you get more levels, that means you get stronger faster. So you can also go like skilled, +2 to all initial skill values, upgrade skill, increase die by 1 level. So you get like a lot of skills. I'm gonna get good learner. Oh, we get 3 talents. Okay, let's go skilled. A very like, oh, great learner. Very skilled. Let's go very skilled. Yes. What is our name? Misty McMixed Face. No, but J is like, you know, it means yes in Swedish. For 6,000 years, the world of Ankara was a serene world. Wait, we're 8,000 years old. We're older than this whole world. Unmolested by the forces of chaos. Here's like, I guess this is a world map. I'm not sure if I remember this. You've entered the Draculor chain across the treacherous mountain pass. The weather is mild and comfortable. A slight wind is blowing a road. So this describes what's happening, what you're seeing. You're seeing a road. This is like a message log here. So you can see now this is the world map. The world map is this big. You see the entire map. So there's no like scrolling in the game. You can't move outside of this, but you and this is what I mean by fog of war. It's like you only see what you've seen so far. So you have to go around and like explore. So here, down here, we have like our name. We have like defense value, I think, power value, maybe. Health power is like mana, I think. Experience level and experience points. Strength, something, 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 something. We have our inventory. If we press I, we have a bunch of things with random stuff in our inventory. I don't remember all these things do. We can change the menu. So here's our stats. Backpack. We have a bunch. We have an anvil in our backpack. Man, that will break your back. Skills. A lot of skills. I think they go up to 100. So once you reach 100, that's max. 0 from 100. So some of them are actually 70 literacy. What the hell? Is that because we're an elf? I guess that makes sense. After 8,000 years, you would know how to read, right? Combat. Swords, clubs, hammers. Yeah, these start very low and it will get higher as you pick up things. Here's the talents that we picked. We have quests, so we actually do have one quest. Find the village of Torinio to learn more about the Dracula chain, current events. Totally 3 important blah blah blah. History, this is my history. Okay. So, yeah, here's like different ways to enter this. A to display unknown skills. Wait, why did I see like all of those? Is it because I did this? Yes. So that just shows different like, you know, shortcuts into there. Now, what you can do is move around. In this game, in basically all roguelikes, you move around with your numpad. And 5 actually means wait, because that you stay put. I can also move diagonally. And I see a road. And this is a cave entry. You can go into the cave. You get a little help there. I don't think you got help when I played. Handle environmental feature. What the hell does that mean? You enter a remarkable cave complex. An easy winds going. You feel life is rife with new experiences to make. Yes, I want to leave. I don't want to go in here. Oh, you need special equipment to scale the mountains. I didn't actually know you could scale the mountains. Actually, I probably didn't know. So you have like these different small types. So as you progress, you see the whole map. The things that you've already learned are still visible here. Now we can go into this this location here. What does H mean? I don't understand. Is that like a generic way to kind of go into something? Congratulations, you have completed the quest to find Torinio. Press Q to all view all requests. We got 5 experience points. But the message was removed. Where did the message go? I don't know. But now we're in the village. And the same thing is here. Like the thing doesn't scroll. So it's like all of the map is not visible at first, but then you go around and you can see the whole map. I don't want to leave the village. So T's, I guess, are trees. If you press... no, I don't want to kick. How do you look around? Okay, so here, L, press L, you can look around. Here you have like a child. Monster memory. I guess if you encountered it before, maybe. So I have a good wife. They don't have any names, I guess. Maybe they do have names, but we haven't talked to them, so... okay, what if we... C to chat. Talk to someone. You talk to the farmer. The farmer tugs a forelock, then Hawk spits and turns away. Okay. They're not interested in us. No, I don't want to leave. And then there's like little houses here. They don't have floors. It looks like. Okay, this is kind of funny. My font is kind of changing the way that it's displayed here. As you can see, the little ellipsis is turned into like a, you know, it goes close, the dots go closer because there's like 3 isolated dots. So it turns into an ellipsis instead of what it should be. That's kind of funny. Okay, in here we have Rint, the village elder. So we can speak to Rint. Oh, cool. I haven't. This was not in the version that I played. Rint, a village elder, grants us villages infested by critters from the caves to the southeast. The village carpenter tried to explore them but was not safe again. It would be great if we could discover his whereabouts. You have a new quest. Thank you. Monster knowledge. What do you remember? I don't know. Kobolds. I don't know anything about that. Okay, 0 to automatically explore the level. That's kind of a crazy feature. It's like if you kind of know that there's no danger anywhere, you just want to uncover every part of the map, you can press 0 to kind of automatically look through everything. And then if there's like a stuff happening, it pauses and you can like act on it. So like if you discover a new monster, it's gonna stop. And so it's kind of a handy feature if you don't want to do everything manually. The Monksip, the human shopkeeper booms. Welcome to Monksip's magnificent Munches Mall. You can pick a handful of wares the ground, expect them to pay if you are convinced. Interrupted. Right, so here we can like buy a bunch of, there's like a bunch of food and stuff here. And there we go. I think I've reached the end. You don't know how to continue. Who is this? Tiny girl. So yeah, I think this has a quest. I think you have a quest. Have you seen my little doggy? Yeah, so you just have to speak to the girl to get the quest. And that's the quest to the top left. So we have like the 2 different quests, right? So there's 2 different. So this is kind of how the combat works. Now this is the little girl's cave here. So if I go into here, I get 50. What? No, but I have to find the dog. Yes. So this is, now we're in the dungeon. This is like procedural generated dungeon. I believe there's a, if you press, there's a way to kind of move. You can kick as well. If you don't have anything else to do, you can kick. And you have like stats of that. Here's a door. If we examine the door, we can see it's a closed door with triangular lock. We can try to open the door with O. Now this is where you can see up here you have K and O. It's like there's a lot of key bindings. So when you play this before, it showed these things. You had to remember everything or press, I think, yeah, you can press like question mark to see stuff here. You can go to manual. There's a lot of things to actually check out here. But let's try opening this door. So it did open even if it had a key hole. What is this? A vibrating ring. Okay. So I picked up the thing with P. And let's look at this ring. Manipulate item. So we can drop it to do nothing. We can equip it in our right wing, a right ring slot, but not while we're wearing gauntlets. We have to actually drop our gauntlets first. Which the thing is, like, equipping and unequipping here takes time. So if I press K, that's gonna unequip, take time. So things might happen at the same time that we don't know about. So I can equip the vibrating ring. Now we don't know what it does yet. So it might be magical. It might be cursed even. So let's put the gauntlets back on. Okay, we got a vibrating ring. So I think once it does like its like effect, we will kind of discover what it does. A small lock. It's open. There's not many enemies right now. And there's like messages coming up. I don't remember how to access those. We got some money. Nice. I think also there's a way to kind of move all the way to the end. Access monster knowledge. This is a female hobgoblin. It's friendly. So friendly means it's actually not hostile, believe it or not. And here's a little bit of stuff there. Okay. Is it friendly even if I move next to it? You're stinking. Well, if it's friendly, we don't need to kill it. I mean, we can also. And the air is in this room is filled with rich flavor. Now, this kind of demonstrates, you know, different rooms can have different like events or different like stuff happening. So this means something. I don't know what it means. It might mean that there's a hidden door somewhere. So you can do a search. No, I don't want to save. Oh, and we find a hidden door. Nice. And here are something. I think it's a bat. A large bat is hostile, and a wild cat. So what we can do is usually like roguelikes, you come into a room through a tiny corridor. There's not much room here. If I stand here and wait, they will come to me, so I will fight one at a time. This is the classic, you know, roguelike strategy. So if I move into this cat, I will attack the cat with my mithril warhammer and mithril longsword. Wait, do I have do I have dual attack or something? I don't know. I might get it though. I don't know if I'm attacking with one thing or two. We'll see. I miss. Cat miss, cat miss, cat miss. It fails to hurt me, so let's try again. I miss again. It fails to hurt me. I hit and transform. Okay, so I basically, you know, crit, like did overkill here. The cat's spirit rises from his lifeless body. Moaning pathetically, plunges to the ground. You hear faint echoing roar filled with hate and sorrow. Okay. That might mean something. I don't know. T to change your tactics. Okay, so you can change your tactics. So which basically alters your, like, if you want to be more aggressive, that lowers your defensive value, which makes them hit you more. But it makes you hit more and deal more damage. Or you want to be very cowardly. If you're facing a monster that's very powerful, maybe you want to be cowardly and try to run away instead of trying to fight it. I don't think I need to worry about that right now. Now, we killed the bat and the cat, and now there's a bat corpse here. The bat corpse is... wait. The bat corpse. Let's pick it up. We can also eat it, because in this game you actually have to eat things to survive. So it's like a survival as well. And here are a bunch of clay. You can, I guess, you can craft things with the clay. I guess we'll. Oh, but now we're burdened. We are burdened. I wonder if you could drop the anvil at the town. Okay, let's just drop. Wait, use a lump of clay? You need a lump of clay. No exciting results. Wait, you can actually craft like clay items? I didn't know you could do this. They are not even consumed. Okay, I'm not sure if you can get something with this, or if this is all that you can do. Usually everything has like a purpose, I think. Okay, you know what? I'm just gonna drop these off. Here is the stairs down. If we want to go deeper, we can also continue to explore this. I'm gonna press 0 to continue. Okay, here is a bow or a club. Let's ignore that club. I am hungry. So we can eat. We have like we can eat the corpse. So there we go. You get hungry very fast in this game. And here is a potentially hostile monster. It is actually hostile. Okay. You miss. Oh man, I get 6 damage. That's a lot. I kill it. I kill the kobold. There's a sling. It's a ranged weapon. Here's another monster. Okay, now here is like... Oh, an iron ration. Perfect. A hobgoblin corpse. I don't know if you can eat that. Some corpses you get like... You actually get... Scale mail. I don't know if that's good. I have elven chainmail. That seems pretty good. We can equip the necklace. We still don't know what the vibrating ring does. I killed the goblin. Wait, did I die? What happened? I was burned by the poisonous touch of impure metal. Oh my god, that could have been one of the equipments that I put out. So there you go. That's the experience of a roguelike. I mean, there's much more to it. Like it's so much stuff in this game. It's like this is barely, you know, it's like a picking up one sand. What's it called? Particle from a desert, essentially, what we did there. But yeah, that is like what's kind of inspiring, in a big way, the game that I'm trying to make. Oh man, time flies. Is the FOV of your character when exploring uncharted parts different based on type, species, or maybe affected by poison spells? I think it can be. I think it... Oh my god. Hello. Yeah. Hello, Christoph. Raid and run. All right. Have a good one. Thanks for the raid. Hope you had a nice stream. Thank you. Welcome, everyone. Ziglings. What have you been up to? Yeah, the roguelikes are really advanced, or complex, I should say. All right, so we're kind of making this game here. I think it's gonna be like a roguelike. And yeah, because I really like roguelike games, and this yeah, and then I'm using this this tile set that was free, and the NPC is like spawned in the incorrect process. But we're making this little town here. But yeah, I wanted to make roads actually. Yo yo yo! What's up? What's up? What's up? What did you do on the stream? All right, this is some zig. I mean, your ziglings, and here you go. Here's zig. I have a string, and I'm using comp time. Well, actually, it doesn't have to be comp time, but I'm basically parsing the string to create a map, which is what you see in the town here. So this is like the result of that map there. So now I want to add roads. So maybe we'll add like roads here. Maybe there's a road that goes through here. Maybe it goes through the whole way. Not really sure. Let's do maybe like this. I don't know. Maybe like this. All right, couple of roads. Let's just try this. So we'll have like plus, minus, and right. So this means road horizontal. This means road vertical, and this means road cross. Yeah. So we need this road horizontal, vertical, and cross. All right, penguin. Okay. Okay, so the roads are are they solid? What do you think? Solid roads? No. They are actually walkable. Horizontal, vertical, cross. Let's find these in the tile set. I think these are the roads. Yeah. I mean, I guess there's one type of road. Maybe there's more types somewhere. There's so much stuff in here. Not sure where this is. And this one, is that? I think that's water. I think so. No, I don't think so. We have minecarts. Yeah, I think that's the roads. Let's just pick these. So we'll have like vertical 27,144. I mean horizontal. That's what I mean. vertical 144 and crossroads 157 144. That should be it. And here we go. We have the little thing. We could also do, what would this be called? For example, this one. It would be like a, well, how would you actually represent that? Though, this is the problem with ASCII, is like you run out of symbols. I mean, I'm thinking like forward slash and backslash, but there's only like one of those. There's also, you could do parentheses maybe. Parentheses. So it's like left. So if you, so let's say left to bottom, or left down or left bottom, will be this one. 53 144. And then we have like left to top 66 144. Right bottom 79. And right, wait, how is the right bottom? Right, and then right top is 92. Okay, but there is no tag named thing. Top, top, right, right. All right. And now we just need to kind of map a character. So I guess if we do like that one, it's gonna be like left, no wait, yes, left bottom. And then the U are gonna be right bottom. This will be left top. And this is right top. So it's very, 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 you know, you see what it is. So this one would be like that. And that, I think. Those are the top, those are the bottoms, yes. I think. There we go. Okay, but now let's add an enemy in here. So when we create the things, this is a temporary here. I just want to do that. So we're gonna say create. We have like import monsters. Monsters. Create goblin at well, we could kind of count here, I guess. I want to create one in the house, like up here. That would be at 46, perhaps. 46 10. If I do this, yeah, 46 10. Okay. Oh, what's happening now? Wait, why was this not working before? Or why was this working before, I mean? How? Because it's a union enum. Is that why? Why did I change it somehow? I don't remember. But now this... So... Wait, no. That doesn't make sense. Expected optional time. Well, what's happening here? No, it's unwrapped. Right, it's unwrapped. No, the tile is... Oh, I see. Is solid. I mean... Okay, let's do this. Let's put that on the tile type instead. Okay. So now we can say... No. We should be able to say that. Why does it say void? Oh, wait. No. We don't need to do an inline else. It's already, we just do this. What the hell? And then we can return tile type is solid instead. Okay. Yeah, I was totally confused there for the entire time. Okay. Are we done there? Now we should have a goblin in the town. I just want to try out the pathfinding a little bit. Oh, it's in the thing. It's in the house. Okay, so that was the wrong coordinate. Maybe I need to subtract 1 from it. Town. Yeah. There we go. Here's the goblin. Why is it not like moving around? Okay, it is moving around. Right, because it's blocked. It's like if it chooses a random... So the way it works is like every time it takes its turn, it has 30% chance to kind of... And this is just for like, you know, testing this system out. But essentially the goblin has a 30% chance to move in a random direction. If that random direction happens to be blocked, it will just stand around and not do anything. So if it's blocked by like all sides, I guess it will just stand there for most of the time. And there we go. Now we've aggroed the goblin. So we can like run out here, for example. And let's see if the path finding will actually work. And it looks like it does. Here, yeah. It's coming around. It should actually work like, you know. Yeah, and now it goes over there. But we don't have like line of vision or anything so that it like understands. It would be cool if you could have like, if you run away so that they don't see you, you could essentially go into like a stealth mode or something. Maybe. I don't know. All right, cool. Yeah, so great. What now? What do we so the thing is, I'm trying to figure out what feature, like how the gameplay will be. Because I'm thinking it's gonna be a roguelike. And the basic stuff are kind of in place, like the turn-based, you know, movement here, and the animations being played in between and stuff like that. I guess, yeah, we don't have like, you can't interact with anything right now, but I guess that will come at a certain point. I'm just thinking more like the core mechanics, like, you know, the combat and all that. I guess it's just a matter of maybe kind of expanding what's already there right now. But for example, if you have a ranged weapon, for example, how are we gonna like be able to aim and stuff like that? So I'm pretty sure I just want this to be a roguelike. So I'm just gonna like I guess vision or something. I don't know. Roguelike. I don't know, I'm not that big on game on the game design documents. I just have like an idea in my head, and then what I see is what you see is what you get. I don't know. Roguelike. It's like a classic roguelike with retro graphics and animations. All right, so we have an overworld we have locations. And what I'm thinking also is I want to be able to zoom in any part of the map, entering a pocket, you know, a pocket dimension that is represents that biome / area. And so overworld encounters, it can be like fights, wanderers, abandoned campsites or abandoned sites or something. I don't know, different things, like just finding like a house in the middle of nowhere, and you get the chance to kind of like, you know, explore and see what you can find. I'm not sure if we're gonna have like hardcore, just like ADOM, like hardcore like survival, like you need to eat, you need to drink, you need to do all that stuff. I'm not sure if we're gonna have that level. I think it's gonna be more. I think that just feels like a system that lies on top of everything that's not really enjoyable in my opinion. Like it's more like, yeah, it's an extra challenge added, but I just feel like it's more annoying than fun having to deal with that stuff. So I think I'm not gonna have that kind of thing. It does kind of remove a potential dimension of gameplay where you like do different foods and stuff. I mean, you could still have food to get like buffs or something like that, or potentially poisonings because you might find food but you don't know if it's good or bad, so you try it and it's like it's a random chance or something like that. Maybe, I don't know. Yeah, of course, there's gonna be like quests, NPCs, towns. And it's probably like, I'm not sure if everything is gonna be like procedural. Like it could be a mix as well. Like a lot of these games have like a mix of procedural. Like the world is well, sometimes the world is set. Like in ADOM, the world is actually not procedural, but the locations, like the theme of the locations are set, but the contents of like the layouts of the dungeons and all that are like procedurally generated, and they even have like different, you know, kinds of procedural generation depending on the type of dungeon or location. But then you have things like the towns. I think they are all set, but we could try to kind of procedurally generate as much as we can. And of course, you know, procedural generation. So I'm not sure if this is going to include like the world and everything, but you know, we'll see. Right now we do have world procedural generation, but it's very simple. It's like, you know, it's just a pearly noise that is very like blobby right now. So you can see here is like, yeah, this is where we have, it's like high height essentially, and then we go into plains, and then there's like a water, and this is just a giant blob, this thing here. So it's like the most basic noise generation you can have. So I want to add like more detailed stuff as well. So what I would do there is like add maybe we'll take another pearly noise, but then we kind of make it more detailed and apply that as some kind of map to apply like erosion or something to that effect. We'll see. But this one, so it's like you layer different like zoomed levels essentially of the Perlin noise to create a more like interesting map. Okay. What else? I mean, of course, there's got to be monsters and stuff like that. Monsters, you know, monsters, allies. And for the quest NPCs, towns, dialogue. Man, this is kind of growing in scope. I mean, when I'm typing this out, it's just it. You need to have the whole package. I feel like almost. It could be all these things. It doesn't have to be. It doesn't. It's still you don't have to do like, you know, a scale that is like obscene. You can do all these things like, but just a slice. That's what I'm gonna try to do. I'm gonna do all these things. I'm gonna implement them in the most simple, basic way first, and then have it as a kind of ground base foundation to add more, to add more content later. But I want to kind of plan out like these are the things, like the main, like the different components that I want to have in the mechanics, like in the gameplay, and then just you could add like when you have the systems all working, you just add a monster. All of a sudden, every area can now have this monster spawn. And so the more monsters you add, the more variation you will get. And in the end, these games kind of thrive on the variations that you get. So like it has like a very high replayability. So you would like, each run would be very different. Especially if you procedural generate the whole world. Although sometimes procedural generation can feel samey. You know, if it's not enough variation, or if you played it, even, you know, if you played it long enough, you can kind of see, you know, repeats after a while, I guess. Kind of like structurally or more abstract repeats. But anyway, that's just part of the that's just how it is. Okay, but I was thinking like, then there's gonna be, of course, there's gonna be like, you know, weapons, like equipment, weapons, armor, magic, you know, spells, of course. I mean, yeah, that goes in magic, you know. Exactly how this is gonna work, I'm not sure, but I know we're gonna have it. Like magic, like, you know, well, yeah, magical weapons, armor, like equipment, inventory, you know, inventory, the usual RPG stuff, level, experience, probably maybe perks and stuff like that. Because it's gotta be like replayability, right? It thrives on variation. Maybe we even have classes. Maybe you can, maybe there's skills. I'm kind of doing a full ADOM thing now. Classes, maybe custom class as well. Like in, you know, Elder Scrolls, you can make a custom class type thing. Just to spice things up a bit. What's cool about ADOM though is that it has so many weird different things. So it's like there's a lot of things to explore and discover in the game, which I really find interesting. It's just adding a bunch of random weird stuff into the game, which makes it like raises the mystery of it. If you just have the normal kind of run-of-the-mill stuff, then it's like, yeah, I've seen this before. It kind of lowers the. But if you see like maybe something that you don't recognize, like what the hell's this, and like why is this in the game? And it's like it's like some weird thing that raises kind of the mystery and wanting to kind of explore the possibilities, I guess. I don't want to really writing that down, but yeah, random shit. I don't know. Okay. Yeah, but this would be the foundation, I guess. Here, there's probably gonna be like maybe we can like procedurally generate like a main quest. You're supposed to kill a boss. Maybe the boss can also be like generated, so it's like you get a different boss. Although that could be. What if you like hate one boss? You always restart when that boss comes up. I don't know. Maybe you discover it in the end. It's like not revealed until the end. You get a random boss. Yeah, that's the way to do it. So maybe there's gonna be a main quest. Main quest. Random boss. Who knows? I was also thinking about like, you know, crafting, building, you know, building, like being able to build things in the game. Not sure what the gameplay implications of that would be, because it feels like this game is not really where you create a base where you return and you do a bunch of stuff. Perhaps, I don't know. Maybe there is a point in like resting up. Like you went into a dungeon, you're all beat up, you have to go and rest in a town or something like that. That could be a good incentive to maybe build a base somewhere to kind of go around and explore the immediate area, especially if it's like more like survival based. Yeah, I guess we'll see. Maybe, I don't know. It could be like an added thing in that case. I do want to get the basic stuff good first. Okay. Well, this is kind of the vision, I guess. Well, it's a lot of things. Welcome back, Penguin. But I have an error on the YouTube thing. I don't see the chat. There's something weird going on with Restream. So I'm sorry, YouTube. I can't see the chat. Well, unless I actually bring it up. I guess I could like have it on the other thing. Are you gonna make sound now? No. You're spelling what I want. Simple as possible. Magic. Next episode so implemented. Yeah. Exactly. It's just you know, this is what the, you know, ambition level. I like, but as I said, it's a lot of things. But I don't have to go super deep into these areas. I just want to implement like a slice of everything, and then see how that like feels, you know. Maybe do like a priority thing, like quests and dialogue may not actually be the most important thing. So I think I'm like the most thing that I want to focus on is like combat and stuff like that, and then quests and stuff like that. That's just like, it's just like, you know, extra stuff that makes the world more interesting. So, but I'm more like a gameplay kind of guy. I like to have like good. It's gonna be the gameplay is the most important thing to me, and then the quests and stuff like that. It's basically just a way to kind of drive your forward. Like it's a way to kind of direct where to go and stuff like that. So yeah. But yeah, this is kind of the vision here. these are very, very important, like overworld locations, zoom into part of the map, overworld encounters, and yeah, okay, monsters, allies, like these are, so if we prioritize this, these are gonna be up there, these are gonna be like at the bottom probably. Procedural generation is just, that's just there essentially. I mean, it doesn't have to be there, I guess, but it's like it's like a method of making the maps, you know. It's like if you want to make a roguelike, you probably need procedural generation because it's, you know, it increases the variation, which is very important in these games. Inventory, weapons, armor, magic is also important. I would put that over there. These things are also important. I mean, everything that is essentially affecting combat, I feel like this is more like a thing where it's like a long-term thing. It improves, you know, your character over time. But getting like the basic stuff in there, and then I think balancing is more important first, or balancing is more important later, but getting the basic stuff, like different kinds of monsters, different kinds of attacks, magic spell system, all that stuff is more important than getting like different classes and skills, especially if the difference in classes is just going to be different skill sets, or different different skill sets essentially. Then it's not super important. And then skills will basically either like enable you to use magic, make it impossible for you to use magic, for example, or different things like bows, or even carrying heavy armor, stuff like that. So maybe, you know, then it's gonna feel like different classes have different like actual playstyle, but that's just because the skills enable or disable you to do certain things. But in the end, you could potentially just have a thing like, let's say you make a custom class that, yeah, they can both cast spells and be a melee fighter, for example, or something like that. That could be kind of cool. But I would want to have these kind of basic stuff in there first. Maybe the weapons are gonna be like, it's like a weapon. Let's say a weapon is it has like different types, and then they will impact in different ways. I mean, let's say you have a two-handed battle axe, for example. Maybe you hit all the way around, or something like that. You always do like a whirlwind attack, or there's a chance to do a whirlwind attack, or something like that, you know? I don't know. But I feel like I want to get those kind of things into the game. More different kinds of monsters, they're like ranged attacks, getting that animation stuff going in there. Maybe we'll do that next, actually. Oh man, time flies. Holy shit. Okay, let's try to actually, I feel, is this, I think also the overworld, that thing is important. It's not as important as monsters and combat and stuff like that. So what I'm going to do is I'm going to move this down here. Actually, yeah, this should come before. This should come before, because otherwise we don't have a use for any of the locations, I don't think. And this is just the overview. And then these are kind of priority list here, down here. All right, cool. Monsters, allies, magic, inventory, weapons, armor, different kinds of attacks. I guess allies. Allies is kind of like, it's kind of like the same as monsters. It's just that they are gonna, you know, attack different targets. So they are not really different from monsters. It's just that they have different like attributes. So I feel like if I implement monsters, or like a good AI for a monster, Right now we don't have a good AI. It's just very simple. But it could be like, you know, a generic AI that has like different kind of states, you know. Then we could use the same for the ally, but you might be able to tweak it a little bit depending on if it's a brave AI or if it's it could have like personality, or man, there's so much stuff. But I really enjoy this because it's like a roguelike. It's like it really sets your imagination spinning, and it just feels like anything is possible. I don't know. I just really enjoy it. Okay, let's try to make like a ranged fighter. So what I'm gonna do is I'm gonna actually make a new location, and we can kind of feel like how hard is it to actually make a new location. So I'm gonna copy this into like, I don't know, forest. Okay, here's the forest. Let's just have, let's say we have like a road. So we'll have like a road here that goes through. Maybe a crossroad. Whoops. All right, and then we have a bunch of trees. Now we don't really have a tree symbol. However, we can provide the function that we provide to map can just say that this should be a tree now. And then we don't really need to do anything with these. Yeah, we'll keep the road, I guess. All right, and then we have like a bunch of trees. I guess. Whoops. Well, I guess small t could be like a different type of tree, maybe. All right, so there's a bunch of trees. It's not really important. The map layout is not really important. I'm just gonna do this, okay? And then the trees are actually not gonna be solid. So let's just add a tree. A tree is not solid for now. How does Zig feel? Hello, Kurt. Zig feels amazing. You should try it. Okay. Oh, oh my god. I can't believe I've done this. Okay, where's the tree? See, it even enters your subconscious. Let's pick this tree here. 105. All right. And there's one there you just saw one reason why Zig is good, which this does exist in other languages. But if I added, I have an enum here. It's a union enum, but it's really an enum because it doesn't have any types here. But anyway, I have this enum here. If I add a new thing here, I will get a bunch of compilers because we have a couple of places that switches on this enum. So it has to be exhaustive unless you're using else, but I usually don't because of this reason. Because now I can just go here and, you know, implement these cases for these things. So that is a really nice help. You know, So that is one of that is one of my favorite features of Zig, to be honest. Like, it's such a simple thing, but it just saves it's incredible when the compiler can help you doing that stuff. Okay, so forest location, let's see, we have setup. We do want to have borders to the overworld. Should probably move that to like a location utils or something. We have create town NPCs. We don't want to create town NPCs. We want to create monsters. And then we have the player position is probably going to be the same. We're going to move the player. Okay, so it's the same thing. We only need to create like a bunch of monsters. Okay, and so let's grab location here, because the location actually has like width and height. So what we could do is we could determine the number of monsters depending on the size of the map. The map size is going to be width. Do we have size here? Yes, size. No. Width. Oh my god. Width times height. And then let's do so now like number of monsters is gonna totally fill the map, so we have to have like some kind of ratio. So I'm just gonna say times you know, actually, will that even work? I don't think so. We have to do like div floor and the ratio of monsters, essentially. So monsters ratio, and let's set that to, I don't know, 0.05 or something. I don't know. Okay, so there's our number of monsters, and now let's go through each of these, and we will generate a monster. We need a position. The position is going to be some kind of random position. So let's do a random. Can you do a random vector? I don't think you can. Can you do you can do a random array though. The type is a I32, size is 2, and let's set this as a board vector. I think that works. Yeah. And then actually, how does this work? Because what would the contents be? You know what? Let's just do this. Board vector equals so this would be like uint at most width no, the first one is the type, I think. Yeah, first one is type I32. Wait, does it have to be unsigned? I mean, I guess, okay. Int at most. Start at 0. Okay, and then we do the same thing for height. There we go. Now we have a random position. Okay. Yeah. So now let's get. Wait, do we have like game monsters? No, we don't. Let's import monsters. Monsters, create goblin at position. Now this could end up on the player, I guess, but whatever. Right now, I'm just trying this out. Okay, so that is essentially yeah, creating a bunch of goblins there. And then let's go to the locations. And we have to actually put this location in here. So this would be a forest. Okay, save. Tell me where to go to fix this, please. Forest is gonna be to actually get this here from layout, forest layout, map, blah blah blah, blah blah blah. Can even just pass in a type to grab out all of those stuff. Enable encounters. The thing is, we don't have... Actually, we do have encounters. We are going to have encounters. That's true. That's true. Okay. Because that was from my JRPG kind of... I basically took a JRPG kind of project. Very simple project, mind you. And then I copied that over. So that was from the base of this. So there's some remnants left there. Use as in the compass. Yeah, so that didn't work. I mean, what if we change? Okay, so we have to change like F size. God damn it. And the number of monsters is gonna be F size over monsters ratio, and we're gonna use size int from float. Oh, F32 float from int. Wait, what the hell is this? This should be times, right? There we go. And now you get a use size, and you want I32. That's right. So let's just int cast that. All right. I wonder if it's feasible with these basic graphics to visualize sun, moon, lightning, eclipses as well. Could look cool exploring the world in the area half-light. I mean, you could probably do something with shaders. I'm not like, even with this like retro graphics, right? I'm not opposed to adding some fancy, as long as it kind of fits, you know, in a good way, the style. I'm not opposed to that. I think that could be cool. Just curious what it, like screen shakes, you know, that's a common thing. Different like animations and stuff like that. Just curious what I think that would work out. Yeah, maybe. All right. Wait, what happened? Oh yeah. So we have the forest location, but it's not on the map. So we have to go to overworld and add it here. Also, where is it going to be? So forest position, let's do 2 above, 1 over, I don't know. It doesn't matter actually. Setup, this creates the town. Okay, and then we have create forest. which is like the same thing, but it's the forest. And this would be forest position. Let's call this location. So really the only thing that's different is the key. It's the position, or the sprite and the position. So create location, key is game locations or location key. It is position, which we could actually set a board. Yeah, we could take the board position. Yeah, and then it was the sprite position as well. Sprite offset. And we do all this crap. So we take from position, oops, sprite, and the key. Okay. And then like create location, town, shared town position. I guess we could store the town sprite offset here as well, which is this here. All right, and then this would be the forest, which we don't actually have. I was like, why does that look like that? The forest, kind of overworld icon. Let's see if we can find one of those. I guess one of these. This one looks good. 1443. Cool. All right, let's get rid of these. Forest. All right. Position. Let's call you board. No. Body position. All right. And here's the forest. And now we're in the forest, and there's a bunch of gobos. Why would they spawn like outside? That's weird. Wow, there's a lot of them, even though I changed the ratio a lot. Okay, cool. Right. Now I wanted to do the range attack. That was what I wanted to do. Right. Okay, so we have monsters. That's right. So the monster, or the normal goblin here has just like a melee attack, essentially. I mean, what we really need, we need like a way for the goblin to attack us. So we kind of need like a range attack action, I guess. And I don't think I have any issues with a ranged attack to kind of break the stiffness of the tiles. Like, it's not going to be like it moves one tile, you know, it's either going to hit the player. Maybe there could be a chance that the projectile hits something else, you know, so that they accidentally hit the ground or they hit another monster or something like that. And then, but that's going to be like pre-calculated. The animation is just going to show the thing go in a straight line. So it could potentially go in a straight line, like at an angle. It doesn't have to be like orthogonal direction all the time. I'm gonna try that and then we'll figure it out. So what I'm gonna do is I'm going to go to attack component, and this is like highly tuned for a melee attack. So maybe we'll even change this to like melee attack or something. Yeah, this is like a melee attack. Let's actually change you to melee attack. Is that how we pronounce it, by the way? Melee. Melee. Sometimes I think I say melee attack. I don't know if that's the accent or what it is. Melee attack. I think that's what we say to each other here in the north. Okay, is that it? Yeah. This is the melee attack. You see, you just essentially what this is like, it's just an animation. It also does have it. Well, the most thing of this is the animation. That this is the only thing it does. Like, it has 1 damage. Where's the on create? And then on create, it actually deals the damage in like directly. And then, so okay, so how this kind of works is that it's turn-based, right? However, if I move, you can see that there's an animation. There's a smooth animation going to the next tile. But as soon as I press the button to choose my kind of action, you can see the white square, it moves forward. The white square is just a debug square that shows where is my current position actually. And then the sprite that you see is just the kind of animation. So it kind of replays what already kind of happened. So, and the same thing goes for the goblins. So the square, like the board state is updated first, and then the animation plays that kind of replays what the kind of animation. Oh yeah, they follow me in here. That's kind of funny. Yeah, there's no cleanup of the goblins, but whatever. So this whole thing is just, it's basically, oh yeah, I forgot one thing. I need to rename this file as well. No. Move to or move to melee attack. Okay. Actually, I do want to create a component. Let's create a ranged attack. Yeah. Cool. Oops. No. I need to fix a whole bunch of places. Okay. Create components. I have to have the actual correct thing here. It has to be kebab case, and that's it. No extension. It's gonna use that to figure out everything. There we go. Ranged attack. Why am I thinking about deranged attack? But ranged attack is a melee attack, a deranged attack. I'm not sure. Let's just copy everything here. This is a ranged attack, which doesn't exist yet. So let's create it. There we go. Not sure if we need to do anything else there. All right. Now, the thing about the duration of this one is like it depends on the like range, or depends on like how far we shoot, I guess, how far it shoots. Whoops. So maybe we'll put in like the distance. Direction is not going to be an orthogonal direction. We're not going to have a direction like that. It's going to be a distance. Maybe we'll have position. It's going to be like position is, so we'll have like start position. And end position, maybe. And this is the end position. Start position is, we need the source. The target, I guess we don't really need to store the target on here, I don't think. Or do we? Actually, we do need, because on create is gonna deal damage. Yeah. And then the duration is not com time known, so we actually need like a I guess, what would this be called? Like frame duration, or animation duration, maybe. Let's have let's have animation. Let's have like is over, like is animation over or something. I don't know. I'd probably need to do some top down instead of doing this, but we're not gonna have this. I'm just gonna delete. We might keep this. We need the action tag definition. The counter is unknown. It's just gonna count how much time is left. Speed, time, duration, target. Okay. let's return false here for now. On create, yeah, let's just, that's going to be the same thing. Move direction. We don't actually have a move direction. I'm going to delete this. Damage number offset we can still kind of have, but it's if has projectile hit or something like that, then we show the damage number. Then we show, I guess that could start the counter actually. That could be the counter, to be honest. So this is just going to be damage display duration. And then this is going to be counter. This is going to be damage display duration minus counter. Over 4. Okay. And then otherwise we return null. I guess if it hasn't hit, we can return null. And we'll do that. All right. Has projectile hit. Return false for now. I guess we need some kind of timing somehow. We need like... Actually, you know what? We need the actual projectile. Projectile, it should be its own... Yeah. The projectile needs to be its own thing. And then the projectile starts at the start position and ends at the end position. Maybe we don't even need the start position then. We just need the projectile. All right, because it already should start at the start position and then go towards the end position. Right, the question is how fast? Well, I guess that will be something for the system to determine. Has projectile hit? So this will essentially be... Actually, this could just be a bool, to be honest. Or we could say... Actually, we could just say... Is the projectile still alive, essentially? Is the projectile... Well, if the projectile is not alive, then it has hit. This is like... If the whole action is over, is action done actually? Is action done? It's a better name for this. This would be like if, I guess if counter is 0. You know what? We don't even need this. Because that's already how it works. The thing though is like we shouldn't update the counter unless the projectile has hit. We don't have a direction, so please don't do that. All right, cool. Okay, now we need a system for ranged attack. Also, I'm gonna go over to component enum. This one we don't want to have here. Also, I forgot about this. I need to add this over here. Wait, and you are melee. And then we need a ranged attack as well. Alright, the range attack needs a bunch of stuff. Oh. It needs a target and a projectile. Let's change this to match the, I guess, the convention there. All right. Cool. Now we can make a range attack, sort of. We also need a system. So ranged attack system. Also, I'm gonna go over to attack system. I'm gonna move you to be melee attack system. And we're gonna rename you. Oh shit, I should have done this first. Systems. Okay, good. All right, there we go. I think, yeah. And then range attack system. Okay, so let's copy over all of this crap, put that here. And now you take over. And you want to grab ranged attack. So, if the counter is more than 0, now here we actually don't want this. We want to say if attack has projectile hit, if it hasn't hit yet, we need to move it. Otherwise we have an else if here. And also we don't do this. But we will have it up here though. Oops. Maybe we'll try to calculate how many frames we need to move. Beforehand, I'm thinking about how to do this, or just we have some kind of direction vector that we just like a step vector that we add a bunch of times, and we just calculate how many times do we need to add this one. We could do that. Perhaps. This, so the counter, we could have a different counter actually. We could have a counter for the projectile. And that will be calculate projectile counter or projectile steps. This will be projectile get body position. Let's get the target position like this. Oops. Actually, let's just do this. Yeah. So product type position is a vector2 type position. This returns a number of steps. So let's do usize. Now, I guess we get like a, so, okay. I guess we get like a distance. So basically, let's do relative should be target minus projectile I think, yeah, because the project position should switch. Wait. If the target is 0, 0, we're 3, 3. We need to go negative, yes. Okay, so that's the relative. And then we have the distance gonna be the length of relative. So now we have the distance. Now we could say that the number of steps would be distance divided by this kind of speed. Ceiling or floor or round. Like it's 1 pixel here and there. It doesn't matter that much. Or one, actually it's 1 step here and there. But I don't want to overshoot it either. It depends on how fast it is, I guess. Let's do whatever. Let's just do round. So it's going to be dist over speed. Now what is speed? I guess it depends. It could be self speed. Oh, we have speed. 1. So 1 means it reaches in 1 go. It reaches in 1 frame. That's a really fast projectile. It's the instant projectile. Wait, over speed. Wait. No, so distance over speed. No. Yeah. I'm stupid. Distance over speed is just distance because speed is 1 now. Okay. So then that rounded would just be distance. So if the distance is 10 pixels, that's going to be 10 steps. So it just means that speed means 1 pixel, essentially 1 pixel per frame. That's what speed means. Yes, and that's correct. I think that's how it's used before as well. So yes, good. Great. Okay, so that's the number of steps, and that's what we want. We convert that and return that. Okay. So now I'm going to say first we have if the projectile counter is more than 0, so that's gonna get consumed first. Then I guess we have this thing happening. Yeah. Then we have a thing. You should be project counter. When the project counter is 0, we are going to say attack. Actually, yeah, projectile, and we destroy the projectile. And then essentially, and then also we move that thing. Yeah. If we're still doing stuff, that still happens. Yeah. Move direction. So move direction would be like okay, so here's the thing. We could store that, actually. We could store the move step as a vector too. Well, thank you, Asanov, for following. Hey, welcome. How's it going? All right. Brain is shutting down. I need to go here soon because it's starting to get late. What the hell was I doing? Oh yeah. The problem is, like, here we're calculating only the steps, but we also have kind of the distance. So let's actually just put a tuple here. This is going to be the steps, and then we're going to have the move step as well. So we have the distance, we have the steps. Let's return steps, and then move step. The move step is going to be relative normalized times wait. No. We don't need to. We take the relative over speed again. Because it's the same thing. But it's rounded. I mean, I guess it doesn't care. It doesn't care. It doesn't matter. Wait, scalar 2. There we go. So yeah. So now we get a tuple there. We get steps and we get move step from calculate blah blah blah. Why is that happening? Oh, right. We don't have self. Why do we need self? Oh, we need speed. Okay, well, let's put speed in there, I guess. Well, I guess we're just using the default speed, so it's just going to be 1. All right. Cool. So here we will do move step. There we go. All right. Now, okay, so cool. Let's do the thing. All right. Oh, cool. Let's go to Goblin. No. Monsters. Goblin. Now let's do, maybe not everyone should do this. Maybe we should have like, I'm just gonna copy this. And we'll do like Goblin Archer state machine. All right. So this guy is just idling around until we attack, essentially. It's gonna have the same behavior, except it's gonna have different like aggro range. So maybe attack. Is going to be okay, so this is like aggro distance. Let's say. Let's just set that to, so this would be tile squares. So I don't know, let's set this to 3 or something. Also, the Goblin Archer probably has a different tile that we can use as well. All right, so if we're attacking, you know what, we probably, I could just move all of this out. Yeah. And do action as well. All right. So if the distance is less than aggro distance, then we try to attack. But let's do a ranged attack now. And we need to create a projectile. So let's just create projectile. Now we also need, well, okay, let's do this. Let's do this first here. Create projectile. Actually, we get a projectile out. So projectile is going to be create entity. We are going to have a body. Actually, it's like box auto. Position is, yeah, position is just position. It's gonna have the same position. So it starts out at the goblin. Size is just the default size of a tile. Options, whatever. All right, so then Direction we don't need. Right. Right, so we don't need direction, right? So we can just say here, we can just say get distance to player is less than aggro distance. Okay. Okay, so project dial. Let's do renderable is rectangle. I'm just gonna do a rectangle now. There might be some thing we could use, but I'm just gonna do this for now. The size, I'm just gonna pick like 4x4, and it's gonna be white. All right. Actually, let's make it red. Okay. Return projectile. Okay. What else do we want? Don't think we need anything else. I don't know. I'm gonna double check something here. Draw renderable. Draw board state. Yeah. No, it doesn't need to have that. I'm not sure what it needs, to be honest. It's just basically it's just you know, an animation being played. So it's just like something that moves along that has a display of some kind. Yeah. Okay. And then that's going to be passed into there. And there we go. And then aggro is like, okay, can we attack? Then we attack and we return. Like, are we able to attack and we attack, then we return. If we can't attack, then we move towards the player, essentially. All right. And right, so that was that. Now this goblin here is like the normal goblin, I guess, variation there. So what if we have like goblin type? We're gonna have like warrior, archer, goblin type. So goblin, so animation key is if, well, I guess we'll switch on goblin type. If it's a warrior, it's going to be goblin. If it's an archer, it's going to be goblin archer. All right, and I will create this goblin archer. Okay, we'll go find this in the giant list of stuff. Did I pick these ones? I think I did. So where's the archer? Is that a bow or a shield? I think it's a shield. Let's find the bow. There has to be a bow here. Is that a bow? Yeah, or a scimitar. It might be a scimitar. That's a pickaxe. Maybe this? No, that's dual wield. All right, we have robes on now. Okay, so we have different classes now. It's like a mage. What is this over here? What the hell is this? a worker or something. It's like doing work. That's a melee mage. Is this like more? This one has to be. No, wait. Is that a dual wielding picking axe? What the hell? I'm not sure. I mean, this could be an archer here. It's up to you to decide what this is, what you're looking at. I might have missed it at the start. This has to be. I mean, this is more like a crossbow. Wait, this has to be the archer. Yeah. This has to be the archer here. I was thinking like a pickaxe first, but no. This is the archer because this is the crossbow and they're next to each other. 2029-53. 2029-53. Okay, cool. So we have the goblin archer. And yes, animation key. So we'll put animation key there. What else? I guess we can have a different debug color. Warrior is red. Archer is, I don't know, pink. And the state machine, right? State machine, initial. Switch, goblin type. Warrior is goblin state machine initial. And archer is goblin archer state machine initial. And then you are the state machine initial. Cool. So now we actually have like we can create different kinds of goblins. And we can actually randomize this as well. Goblin type is a random enum value. And the enum value is monsters goblin type. That is public. Wouldn't it be cool? I'm saying this a lot of times, I feel like now, but if enum value, like look at this. This has like a comp time type. Yeah. So this has a comp time type. And it's the same type that we return. Because it kind of it depends on what you want in the result location. But what if you could have this, you know, depend on the result location instead? Because if like functions like splat, for example, which is a built-in, it actually has like an any type return type, which depends on the result location. I wish we could do this in normal functions as well. I don't think there's a way to do it right now. But that would be really cool because then you don't have to specify the type. It could be just depending on where you use it. That's gonna get kind of inferred. That would be really cool if you could do that, because then here, for example, instead of doing this, we would be able to just say random enum value, and it would know because the result location, you don't have to pass it in because of the result location, it already knows what it is. All right, anyway, I have to go now, but let's try this here. Oops. What? Why is... Okay. What's happening? Failed to check cache. Oh. Do we have too much happening here? Okay, yeah, the space on the disk ran out because Zig, basically every time you compile, you get like more stuff in the Zig cache, and it never cleans it up. So I don't know if there's a setting you can use somehow to mitigate that, but sometimes it can grow to several gigabytes, and I have to go in and delete it sometimes. Monster... Wait, what? Value with comp time only, type depends on runtime control flow. Comp time only, type function. Oh, it's the function is the issue here, right? Oh, okay. I think... What if we change to inline? Does that work? I mean, this is kind of stupid. What if you do like inline else, you get the tag, and then you switch on T, because now that's comp time. And then... Wait, does that even work? I feel like this should already happen, but yeah. I'm not sure. Does that work? No, that doesn't work. Wait, Goblin types no... Oh yeah, it's warrior. No. No, that doesn't work. Okay. So... But I feel like this is like... It's not like comp time. It's a... what if we set this? No. What if we do this? Does that work? Okay. So this apparently works. Okay, the more you know. I never actually done that before. Like having to say address of function. Cool, the more you know. I wish it would just, you know, do that instead by default, but yeah. Unable to resolve comp time value, animation, get animation key. Why is this comp time? Wait, do you require a comp time? Oh my god. Could we not do you comp time here? I guess we could, but then we have to do a switch here actually. Okay, you know what? I'm not gonna deal with all this. I'm just gonna do... create Goblin Warrior. yeah. Goblin state machine initial goblin red. We don't have goblin type. Goblin archer. Pink. Goblin archer. Goblin archer. Alright. Whatever. I tried to do it generically. I can do it, but I'm kind of in a hurry now. So, like, switch on goblin type. If it's a warrior, we will create a goblin warrior. Game board position. If it's an archer, we'll create a archer. Alright, there we go. Are we done? Let's test this, and then I have to go here. Okay, we got a bunch of archers. Are you gonna shoot? No, you're gonna crash. Actually, you're not gonna do anything because... Is anyone attacking? No? Okay. So, somehow it gets stuck. Oh, whoa, 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 whoa. I know why, I know why. I forgot to add this here. We have to... I have to change you to melee attack. Okay, let's try this again. So as soon as I enter, will they actually attack me? Probably not. Oh, there we go. It actually, like, attacks. Does it crash now? No, it doesn't crash. So it did, like, a range attack. But then somehow nothing is happening. Okay, so it got stuck somehow. Okay, but yeah, cool. So I'm gonna continue this next time. Thank you very much for watching, and I hope you have a nice day, and I'll see you later. See ya. Before we leave, I guess we'll raid something. Keep this going here. Do we have any zig stuff happening? There's never any zig stuff. Wait. Oh, there, I found a zig. All right, let's go. Let's go, let's go.